A very good afternoon to all of you, and hopefully my video and my I am if you all are able to see me. Anybody can
Yes,
say
sir.
yes, yes, sure,
Yes, sir.
sure.
Yes, sir.
So thank you for joining and patiently and very eagerly continuing the great learning experience. It is very good to see you all people very motivated, and we are highly we are thankful to all of you for your continued information and continued learning. We have started receiving the submission of assignment, and it was very satisfying to see that. Uh, Therefore, I am straightway going to my talk and started sharing my screen. Uh, it is fine that if the assignment is available on day 4, it's if it is submitted, it's fine. So you can now ignore the days it on specific days, but it is fine now. So if you are able to download it and submit it through the browser at the web portal, that is fine. Hopefully that answers the question. Can I move towards my presentation, please?
Yes, sir.
I think both can be submitted in the same link, and there would be a provision for that. Slightly we have discussed. So if still there would be some thing to discuss, we can take it during the break session or when we end the today's day. So let me share my screen. Hopefully my screen is available to all of you.
Yes, sir.
Yeah. Okay. Thank you. So from today, and technically speaking, from today and coming 4 days, it will be a real exposure to statistical learning and the hardcore data. So the actual thing of data and the actual thing how the statistics works. It is very easy to get. Well, it is not so easy, but we do get results from software, and we interpret the things on the basis of some testing of hypothesis and other things. But what goes inside and what goes behind such how the things behave, how the things work, and how the statistics plays its important role at the back end. That is the focus of today's presentation under the this for quantitative data analysis. So personally, I have planned my presentation in these topics. So I will be giving a brief background. Then I think it is important to understand the historical landmarks and the historical development that took place in the area of statistics and how statistics became the branch of total mathematics, or somebody also argue that it is a separate branch of mathematics. It is has been derived from mathematics. That is a different altogether. We can take calls, we can discuss on this, but statistics has its own history. It has its own historical perspective, and it has its own historical background and development, and different individuals, different scientists consisting of mathematicians and other statisticians led to the development of this process, and how the statistics involved over a period of time. That will be the focus for history of statistics. I will be touching in great detail the following three sections: the research process, the normal distribution, and test of significance. So that will be the major thrust. So if we try to see the in pie chart, that what is the distribution of the plan that we have been talking. So 50% of my talk for today would be devoted exclusively to test of significance, where we will be discussing about data structure, different types of statistical tests, and many other things, which is very important to understand before we actually go to analysis or plan some proper statistical analysis as per our research protocol. So a normal distribution will be discussed little bit more. However, I will be touching my focus will be slightly less on background and history of statistics, but to some extent higher on research process or research hypothesis that is there, that will be there. So, as all of you know, this is the AIMS building, and Indian Institute of Medical Sciences was being established as an institution of national importance by an act of parliament in 1956. And the trinity of the objective, the main mandate of the institute is, in fact, clinical care, teaching, and research. So we have faculties who are involved in clinical care, teaching, and well as research. So these are the three mandates. Uh, I am specifically working at National Drug Dependence Treatment Center, which is located as at a physical distance of about 36 kilometers from All India Institute of Medical Sciences. Uh, it was established as a de-addiction center, and its previous premise was at the Deen Dayal Upadhyaya Hospital till 2003. But because of the active involvement in epidemiology and public health projects and community development programs, and too much of emphasis on public health aspects of affective disorders, the Ministry of Health and Family Welfare upgraded the center, and we are totally working from our new operational area under the premise of Ghaziabad in the CGO complex at Sector 19 in Ghaziabad. It is called Kamla Nehru Nagar. So it is located at a physical distance of 36 kilometers, and in 2003 it was upgraded as the National Drug Dependence Treatment Center. If we try to see the basic mandate of our center, National Drug Dependence Treatment Center, or it is called NDDTC in short form, there are four basic things that we do. Clinical services, of course, consisting of OPD and IPD and other community developments, and capacity building, which is the part that we are trying to discuss from 15th of July. So capacity building in terms of statistics. Also, my involvement as a biostatistics faculty is on a capacity building on statistical methodologies and statistical perspective. There are many other public health activities, and also the research, which is the mandate of our institute. There are large epidemiological studies that we have done, for which some were done before I joined All India Institute of Medical Sciences in 2012. These are the different list of major epidemiological studies that has been done. Recently, after joining All India Institute of Medical Sciences, I was privileged enough to work with my fellow colleagues in the Department of Psychiatry and National Drug Dependence Treatment Center on three major public health research projects, which was very good experience, a good learning experience, and many things that probably we used to learn in our statistical period or in our statistical classrooms, how they can be applied in real world, in real life setting. That experience that helped me a lot in gaining all these things. So it was one of the study was Punjab opioid dependence survey. Then other was mapping and size estimation of street children who use drugs in Delhi, and the recently completed national survey on extent and pattern of substance use in India. uh, my involvement as a national investigator and also as a lead biostatistician in this national survey, the report is available online. Anybody can browse that and see that, and all the fellow colleagues who were who were the national investigator in this, Professor Atul Ambekar, Dr. Alok Agarwal, Dr. Ravindra Rao. You all people had the privilege of listening to Dr. Ravindra Rao on the epidemiological design. Then our present head of department, Dr. Rakesh Kumar Chadda sir, to whom you listened on the inaugural, and our previous head of department, Professor S.K. Khandelwal. They all were the national investigators. This report was submitted, and it is public. It is available in the public domain. My specific role on this project involvement was developing a protocol on the statistical aspects, how to then state-wise determination of sample size, developing state stratification modules, and there were different at all aspects and all phases of the implementation of this particular project. My involvement was there along with my fellow colleagues, who guided, and all of us guided each other and cooperated well, and this study was completed. It is available. So, and of some of the publications which we have just published in last few years, in last 1 year specifically. This is a very prestigious publication of one of our study from that I showed on mapping of state children who use substance use behavior. It was published just few months back in BMC Medical Research Methodology, a very prestigious journal in the field of applied statistics, regarding diversity in substance use disorder among street children of Delhi under Bayesian approach. So so for this for under this we estimated that what is the variance and what is the behavior of street children, what they, so in fact it was totally a new approach of probability application in the field of substance use, and how the substance, what is the diversity in the substance use behavior of street children of Delhi under a Bayesian paradigm. So the dear Dr. Vivek Verma was the first author and I was the corresponding author in this publication, and you will be listening to Dr. Vivek Verma from tomorrow for 2 sessions. The next was also the a prestigious journal of Asian Journal of Psychiatry that we published, estimating the size of substance using street children in Delhi using a respondent-driven sampling. I have not planned exclusively and explicitly to discuss in detail about respondent-driven sampling, but if some question would be there and time permits, we can do discuss. We can also discuss about other things if you people will be interested or time permits the same. So with this background now, exactly we come to little bit and talk for a few minutes about the historical background of statistics, that how, what was the history. In fact, history, the word is Latin, in Latin, Italian and German respectively refer status, statistica and statistic. Of all we mean, they mean by that what is the political state of a country, of any particular administrative unit or a country or a region or a continent, whatever you can see. There has been different landmarks in the field of the development of statistics, and the most important of them was the Francis Galton work on regression and Carl Pearson work of correlation analysis on and chi-square test that is widely used. And it was in the era of Carl Pearson that acceptance of statistics as science started holding its own prominence. And the famous student T distribution given by Gosset in 1908 was another landmark. And R.A. Fisher, Professor R.A. Fisher, is called as the father of statistics because he applied all the statistical methodologies in different domains of genetics, biometry, education, agriculture, point estimation, exact sampling distribution, analysis of variance, and design of experiment. That's why he is called as the father of statistics. During there is a mentioning of statistical work during also in the ancient times from Chandragupta Maurya, Kautilya Shastras, vital statistics, and during Akbar reign in Anne Akbari and Abdul Fazl also mentioned about them. In Germany, at the end of 18th century, there was a method of recording of information of official statistics. In England, it occurred because of the account of Napoleonic War. Yes, Akhilesh, you want to ask something? In England, it was we will be I will be addressing all the questions at the end of my presentation, so you all people can go on typing, no issue. I will be able to take up at the end because it is not possible to go for carry on, no issue. So in England it was on the account of Napoleonic War and assessment of revenue and expenditure that used to incur in different battlefields from large areas. So that was the application of statistical methodology in during the England. Uh, in fact, the two most important people who are regarded as the backbone, that is that are giving the concept of probability, are Pascal and Fermat, and also the work by James Bernoulli on the theory of probability, and the doctrine of chance by De Moivre, and the history of probability by Laplace, theory and principles of least square, on the basis of which the concept of Bayesian paradigm is there. That is the landmark applications of statistical methodologies that led to the development of this field. Florence Nightingale, many of you would be knowing, especially in the field of nursing and in the field of clinical sciences. She is regarded as a who was famously called as a Florence Nightingale with the lady with the data, the lady with the lamp, and also the lady with the data, because she was one of the most prominent statistician in history. She was a very passionate statistician, saving lives of soldiers in Crimean War. Data visualization, influential event to date, but how the data can be visualized by different shapes, different diagrams, and in newer innovative method, that were her contribution in about 250 years back. And his and her work on all these the data visualization techniques and his passion in the application of statistics during the Crimea War among for the soldiers led to the significant reduction in the mortality rate. However, as the time involved, as we move forward, the history of biological thoughts and biostatistics came because of the work of Mendelians and Dorism, and there was an exponential application of statistics because of the Mendelian inheritance and Dorism in and computational process. So that's complete my two part. I made quick, but now I'll be a little bit more slow on this. So, so this is the workshop on analytical techniques for statistical analysis in mental health. Before we go for analysis, it is very important for us to understand that what are different steps of research, what are the research process that are important, because there is a famous saying that to call in the statistician after the experiment has been performed can be no more than asking him to perform the post-mortem, or he or she can only tell that what the experiment died for. So that's the significance of statistics. Not many people used to perceive statistics that it is only the analysis and analytical techniques. It is not that case. In fact, the role of statistician in every field right starts from where the research is being initiated, not only for the process of data collection, but how exactly that research was visualized and how that research was carried out, and what are the different ways of carrying out that research work in a more better way, so that a meaningful conclusion can be drawn once the process of data collection and the analysis and interpretation is being done. Uh, Going on a personal note, during my chronological professional journey that started about a 2 decade back, and uh, uh, by the virtue of God, I have been privileged to work in premier institutions of national importance, and also in few of the international assignments that are there. The one thing that I have always tried to emphasize upon the field of statistics, that statistics is not only data analysis. If any people, or even if this is the perception among statisticians, I would slightly differ, and I will have my own reservations over it, because we should see our role not only at analysis or analytical persons or only as a data scientist, but also much beyond that. That means for the right scientific approach and active involvement from everywhere, right from day one to day last, for a particular academic career or for a particular academic journey. That is important. So if we try to see the different steps of research process, there is a research problem. So we start with a research problem, we review something, then we create our own hypothesis, and then we design, that is the research design. Then we collect data and we analyze and we interpret. However, the the first three, that the research problem, review, and hypothesis, they are not totally statistically oriented. They are partly oriented in a statistical fashion, and they are but however, when we come to the research design, data collection, analysis, and interpretation, the sound knowledge of statistics is very important, because all these four things can't be worked upon adequately and systematically if we don't have a very sound statistical knowledge in our own working sphere. So that's specific, that all these four steps are there. And however, one should not see these processes as a linearity, that there is only a forward loop. In fact, we can go from defining a research problem, do a review, create our hypothesis, have a research design, data collection and analysis, and interpret. But once we have interpreted our results, it might be the results might not might not corroborate with the prior hypothesis or research problem, and we might have to revisit our research problem in our review and our hypothesis and even our design state to see that whatever result we have got after we have collected data and analyzed and interpreted it, whether that is making sense to us or not. That's the main, that's the very important step, because many people among researchers, due to the paucity of time or many other limiting factors which are beyond our control, or in any academic environment or in any research scenario or institutes, it is important to understand that the process of research or a research problem is not a one-way loop. It is a forward loop as a back and also as a backward loop. We can grow from a research problem to the interpretation, and but again we have to go back from our interpretation to research problem to find out and see that whether what we have conceptualized at the initiation, that was right or not, whether we provided the proper review or not, did we framed our hypothesis correctly or not, and was our research design adequate to answer the research problem that we are trying to say. That what Dr. Ravindra Rao has given you by the 5 MCQs, that different observations, and you will see that those MCQs are not so easy to solve because they have a practical orientation and they have a practical clinical scenario that has been given. So that's what is important usually. So that's the, I will always emphasize the that throughout my career, in fact, and even in this workshop, that statisticians should not see statistics only as the analysis. It is important to see many other domains. When we have done research, we try to give some disseminate that research in some conferences or in workshops like this, or publish our paper. And when we try to publish our paper, we do have to adhere to some internationally accepted standards and guidelines. This is a very famous, some of you would be knowing, and some for you, for some of you it would be a totally new thing to learn, that there is a network which is called as Equator Network, which is enhancing the quality and the transparency of health research. And you will find different guidelines, that how reporting guidelines for many study types. So it is a good part that these guidelines are available in the public domain. But there is an another aspect of this. There are also different impediments in the research processes which are beyond our control. For example, we did this study about 2 years back. It was published in another prestigious journal of substance use and misuse. And we what we did, we tried to find out that what are the instruction to when we try to submit some paper and prepare our manuscript for submission. We prepare according to some guidelines, and when we prepare according to sub guidelines, we see the journal to where we want to target, and then we go ahead about making our manuscript according to that particular requirement. However, when we try to see that do addiction journals endorse unbiased reporting of research, a systematic review of instruction for authors. So what we did, we took about 1200 articles consisting from 6 databases, and we found out that 88 articles are there, 88 journal titles are there in the field of addiction sciences, or in or journals which are exclusively devoted to affective disorder. And to our and if we try to see the about the frequency or the percentage of reporting guidelines like consort, prisma, start, strobe, ICMJ, and clinical trial registration, we find that if we compare with our study with the psychiatry, we can find that these guidelines are endorsed to a lower extent in these instruction to authors of these journals. So what does this mean? That even when we have prepared our manuscript, and even when we have adhered to the guidelines of the instruction to authors, it might be possible that the instruction to guidelines for those particular journals may not be sufficiently enough, or they may not be adequate to prepare the manuscript on a certain standard. So be aware of thing, and that's why the understanding the process of research is important. That's why and it was one of our good paper that we came out. So now we go straight away into the hardcore domains of statistics. And as many of you, if you could recall, during the inaugural address, I just emphasized that statistics deals with collection, analysis, and interpretation of data. So these are three domains of data involvement. that we do in statistics. However, if we see the hierarchies of statistical application right from bottom to top, it is in my personal view and in my academic journey, I try to see this in a very different way and try to provide the perspective sequentially so that all of you understand the essence and what I'm trying to probably say. At the bottom is the probability. That means everything is probability, because one should understand that the statistics is, for statistics the backbone is probability, because we guess something when we try to estimate something on the basis of certain parameters or certain statistics. Above that goes the descriptive statistics, then we go for inferential statistics, then we go for correlation and regression, and we go for a time series analysis. So that forms the one part of one third of the pyramid or the apex, you can say, that as we move up, the next part is more of a little bit also a statistically, purely statistical in nature, but it is the second, the you can say the middle part is quite robust in terms of the robust application of statistical methodologies, because there we deal with pattern recognition or cluster analysis or factor analysis and confirmatory factor analysis, and this all has been planned. And so some part or many things we will be discussing during the coming 4 days starting from today. And the upward, the most important of all these, the upper pyramid goes in this way, that we want to evaluate something, and we want to do a systematic review and meta analysis of randomized control trials or other things, so that we can find out that yes, where what evidence has been gathered, and that whether the evidence that has been gathered is sufficient enough to create some hypothesis that we can do. We will be taking exact example in our from the as we move forward. So this is how personally in my own academic journey I visualize the different three different domains of statistical application in terms of when it comes to the complexity of applying a specific statistical methodology right from bottom to the top. And mental health, if we see, that is right, it starts from the second part of the pyramid, where the importance of pattern recognition, cluster analysis, factor analysis, and confirmatory factor analysis is very important, as rightly mentioned in the inaugural address by the dean research sir, Professor Subrata Sinha sir, that in psychiatric disorders we generally deal with a small sample and large number of variables, and we need techniques like factor analysis and confirmatory factor analysis under the structural equation modeling approaches to reduce the dimension and understand some profile or some prediction of those psychiatric disorders. That's why I say that mental health, it is not that mental health will not use the time series analysis or correlation and regression or inferential statistics, but the frequency with which the role of CFA and factor analysis is more higher in mental health as compared to the other specialties of medicine. That's what I mean to what I mean to say. This is a very good snapshot of I was reading about 10 years back one book on research methodology, and I was very fascinated and very admirable. It was a very adorable snapshot of in fact, if we go to see these all the things, if practically this is all what is done in statistics at the basic level. So one can go about processing the data, one can go about describing the data or doing the analysis. When we are processing the data, when we can, in fact I will be going little bit all, I have separate slides. So like we can go for a data processing or data analysis, so we can go for editing, coding, classification, tabulation, and percentage. And remember, this process, the data processing, is very very important. And I would advise all of you that after this end of the workshop, those many of you are very familiar in Excel, and some of you it would be your first use of Excel or application. Please use Excel, and there are many functions, many database management strategies that are available in data processing. It is very important. The more you devote time to data processing on editing, coding, classification, tabulation, and percentages, the more better and well informed we all will be in the process of data analysis. So data processing goes in this way. Data analysis goes in under the descriptive and causal analysis, and also the inferential and statistical analysis. When we can have a descriptive and causal analysis, we can talk of a unidimensional analysis, we can have a bivariate analysis, we can have a multivariable analysis, and we can have a multivariate analysis. Many people used to get confused with a multivariable analysis and a multivariate analysis. Scientifically, technically, and statistically, these two terms are totally different in nature. Though at the first instance, in terms of, say, if you talk in the perspective of English literature or in a normal communication, it looks to be same, but they are technically totally different. That we will be discussing. Under the data analysis, we have inferential statistics, and under the, you say, inferential or inferential analysis or inferential statistics, or the hardcore statistical analysis that is there. Then we can go by the estimation or the testing. If you go by the estimation, it can be a point estimate or it can be an interval estimate. So for example, if I want to find out that uh, what is the total count or total number of participants in this workshop, that is what I am estimating, and that we estimated on the basis of a systematic web based portal data application, and we got the registered participants. You all people activated those accounts and we got a count, so that is an estimate. However, if we are interested in finding out some, want to do some testing in that, then we can find out that among those registered participants, how many of you have continued for all the 9 days, and how many of you could not continue for 9 days. So that's the analysis part, that is the testing part, and we can apply a specific test or a non-parametric test to find out whether there is significant difference or that is not. We will be coming to it. For example, we can have that, is there a, whether the proportion of male participants in this workshop and female participant in this workshop is the same or they are the different. That is what is the testing is there. However, when we go for a, when we talk of testing as such, we can apply a parametric test as well as a non-parametric test. There are special situations, there are special consideration on the basis of which we decide this. When we talk of approaches under the under the univariate, when we say univariate, a single entity, we have many things, in that. In fact, statistics, we can, under univariate, you can have a measures of central tendency, dispersion, skewness, location. I am not covering all these four because all these four are known to all of you. All of you would be are involved in research, so you would be knowing that what is mean, median, mode, standard deviation, range, or quartile deviation, or variance. All these things are will be well versed. What is the skewness, what is positive skewness, what is negative skewness, what are locations. So we'll be more starting upon from the analysis of variance or the bivariate. So when we talk of a bivariate, under the descriptive or a causal analysis, we can do a simple correlation and regression, which is the part of tomorrow's lecture. We can do a partial correlation and regression. Then we can have association of attributes, like we did the exercise on CD4 count on ELISA of their HIV status, and what we estimated rate ratio, relative risk, and odds ratio in the epidemiology exercise that we did yesterday. And we can do a two-way analysis of variance also under the bivariate approach. When we talk of a multivariable approach, when we talk of a multivariable, we are going ahead of two variables. When we have more than two variables, we go for a multiple correlation or a multiple regression or a multivariate analysis of variance or canonical correlation or cluster analysis or factor analysis or confirmatory factor analysis. However, when we go to a multivariate analysis, we do a multinomial regression, count model, linear mixed model, model with time variant, modeling of multiple events, factor analysis, and confirmatory factor analysis. So these slides are just to say, when we go for parametric inferential, we can do under a parametric test, we can do a one sample, two sample, one way ANOVA, two way ANOVA, and one way repeated ANOVA. And under a non-parametric, we can do a man-Whitney U test, Wilcoxon, Sign, Kruskal, Wallace, and Friedman. Up till this point, exactly that what exactly we mean, my intention was to give you a broad perspective starting from a univariate to a multivariate process, what is there and what is the backbone and what statistical application we do. Now we are going to more specific, and we are moving little bit to on a more complex side of research process, as from now onward. So once, as we discussed, that we have research process, which starts with the research question. So the questions, that there can be multiple questions you are addressing at the same time, there can be few questions. So the very first thing that we can think of, that what are we measuring. Matlab, are we measuring, what are we measuring means, that means what is being measured, how, then what are we measuring a categorical data, are we measuring a continuous data, are we measuring the height of an individual, or we are measuring that how many proportion of individuals had a among pregnant, among women who were given counseling for exclusive breastfeeding, among them how many children got reported diarrhea. So dot what, so one becomes the categorical data, one becomes the continuous data. So that is important, that what we are measuring, what are we measuring, the very first thing that is important. Then then question arises, what question we are answering, in what way and what question we are answering, and how we are measuring. Suppose we are measuring anxiety, and suppose we are measuring anxiety, so how we are measuring, it is being assessed by an interview. Can we use Hamilton anxiety rating scale, and then is single question being answered, or more than one question is being answered. And if we try to see, all this, then what we, when we say what are we measuring, that is our domain of hypothesis or our domain of research application that we are talking. When we say what question we are answering, then what type of question we are answering, that means there is how the choice of a specific research design will be required. If we are going prospective, you will do a cohort study. If you are going retrospective, we will going a retrospective cohort study, or we will going a case control study. Or if we are measuring the same thing within a small time, we will go for a cross sectional, or we are performing some experiments. Suppose we are interested in finding out that what are the improvement in the psychotic symptoms be given by some certain medication. Then our question is that whether there is improvement in a particular psychotic symptoms or not. That can be measured, say, probably by brief psychiatric rating scale. And over a period of time, we may be interested in finding out that whether there is significant improvement in the on the scores of on the BPRS or not. So that's the type that is important. Then data collection, some usually in psychiatry and in mental health and affect and addiction sciences, we deal with some many of the skills that is there. Then clinical assessment, then specific instruments, and is a single question being answered, or is there is or there is more than one question answered. So if single question is answered, that becomes the primary objective, and if more than one question is being answered, we should have a secondary objective. Now when when you write a protocol or a exam, when you write a whenever sometimes researcher write a protocol and submit to the funding agency, because when we also sometimes get the chance to evaluate as a reviewer, or also as the grant reviewer or the other application, we want to see, it is a very important thing, that what is your objective. And uh, primary objective should be that objective which probably you can achieve, because many of people say, okay, I make this hypothesis, I make this objective. If this objective doesn't fulfill, or my data doesn't support or answer this first objective, then probably my second objective or secondary objective should be answered. That is a totally a wrong approach in my opinion, not even in my opinion, or in fact to anybody in the scientific world. Uh, Primary objective should be the objective which should be backed by a much important, solid review. However, secondary objective also holds its importance, because you might be interested in, for example, if you want to find out that whether the on the when we apply a BPRS and whether there is any improvement in the psychiatric patient the scoring or not, their secondary objective can be that whether there are some differences on the basis of their social demographic characteristics or not. So if there is no improvement at the first place, or it remains the status quo, it doesn't make any sense to fulfill the secondary objective, because your primary objective is not fulfilled. So must devote much collaboration and discussion during the protocol should be made for the primary objective. This is a one publication from New England Journal of Medicine. I think everybody should go through it, read through it. The what they did, that they created the database of all the clinical trials, and they provided an update and key issues. You can see that outcome measures reported trial per outcome measures reported trial. So that means when you are applying some research question you are making, and we want to make some outcome, that means whether there is improvement of a psychiatric condition, there is an improvement in response, there is a better adherence to a treatment, or there is a better compliance to a particular treatment or therapeutic regimen. These can be then outcome measures. If you see the estimate that the median was one, that is 50% of all the trials reported only one primary objective, and their interquartile range was 1 to 2, that was fine. But if you try to see the full range, that means it is 1 to 71. That means partly it can be attributed that in mental conditions and in psychiatric disorders there can be many we apply many instruments and we apply many scales and instruments to understand the behavior of interest. That is important. However, when we but you can see that there is a quite a lot of variation in the range of the number of primary outcome measures that were being reported per trial. So these are the four levels that those clinical trials update said that at the when we try to describe something, description of measure at a specific time, we can have at level 1, level 2, level 3, and level 4. We can have domain specific measurements, specific metrics, and method of evaluation. So when we have a level, it can transgress from anxiety to schizophrenia. So we can have anxiety, which can be measured by back inventory anxiety. In between this phase of depression to schizophrenia, we can apply. We can. I will request somebody to please mute themselves. We can apply Hamilton anxiety rating scale. Then second level is specific measurement that what change we are expecting or any end value or a change from baseline or time to event. Then level 3, this is there, and level of aggregation, that how we are trying to analyze the data and report the data. So one should see this article and one can see that when we try to aggregate or assimilate the data after analysis, we can go by a quantitative approach in terms of continuous and also as a categorical. So when we can have a continuous, we can go for a mean, we can go for a median, or no, on the basis of categorical, we can have proportion of participants whom there was a decrease of more than 50%, or proportion of participant with a decrease of more than 8 points on a particular on a scale by HRS. So that's the different levels of reporting there. So that's completes the one major part of the research process, but which I conveyed right in the beginning, that the major thrust is on three things: the research process, the normal distribution, and testing of hypothesis. Now normal distribution, a very important distribution, and every statistical theory, whole sampling distribution, parametric test, the assumptions, they are based upon the application of normal distribution in statistical theory. Now, what exactly normal distribution? We will try to dissect it in detail and see that what exactly it means. For many of you, it would be a revision. For many of you, you would be knowing, but probably you would. I think that there would be something new in this course of presentation that probably it will be new to many of you. So, suppose you are working in the field of self learning disorder as a dyslexia, and you order and you collected the information by applying some IQ scale, and you have the IQ score, so distribution looks to be something like this. So when we try to plot a histogram, it looks something like this. So it is pretty looking to be normal, because there were some observations which were low. After as during the its progress, it has started increasing. It reached its peak and it went down. So that's a typical symmetrical normal distribution that is there. If we try to see this to a little bit on an other side, so we see that mean is on that is mentioned on average, majority of the people are centered around the central axis, that along this line. If we see the left half of this and the right half of this, that means total area, if it is 100%, or zero point 0.5 to the left hand side or zero point 0.5 to the right hand side, that means 50%. That means 50% of the individuals will have their values of IQ score less than the value of the mean, and 50% of them will have more than the mean. In the same way, if we try to understand what is the median, what does median does? Median bifurcates the data distribution into two equal parts. That means median is the midpoint value. That is the midpoint value, and that's why when we see that midpoint, median means it is, if we say 50% to the left and 50% to the right, this is how the median looks like. And if we try to see the mode, If you try to see the mode is also at the higher side. That means you can see that the mode is, that means the maximum. So you can see the maximum value of this is occurring at this point. So that is the mode. That means right hand side and left hand side again all are 50% less than value of mode, and 50% are more than the value of mode. So that is there till the what so if you try to see the same thing so that if the data is normally distributed, then what will happen, that mean, median and mode will be, but technically they will not be coinciding exactly the same. That means if you estimate the average VPRS score of an individual and you find out that the mean value is say 49, and median and mode are 49 and 49, it will not occur like that. It will be something like say 48, 49, 51, or 65, 63, and 62, something or that. They will be little bit closer to each other within the closer vicinity, and that's what exactly we mean by the normal distribution. So that's the typical. So when we see that, it complete that you go to the right hand side and to the left hand side, you have three confidence limit. That means how much standard deviation we are going away from the mean to the left hand side, and how many standard deviation we are moving ahead to the mean in terms of standard deviation. So it will be more clear in this. So when we see that if the data is normally distributed, about 65% of the value will be measured within the mean plus minus 1 st, that is 68.3%. Within mean plus minus 2 st, 95% of the values will be there, and within 90, and within mean plus minus 3 st, about 99.7% of the values are there. Now many a times when we used to discuss during my academic career about the normal distribution, students and even the researchers used to ask why we only take mean plus minus 2 st, and why we do not take mean plus minus 1 st and 3 st as a reference standard. Now there is an explanation for this. When we are using only mean plus minus 1 st as the reference standard, we are ignoring about 32 to 33% of the values which may be outside that limit. So quite a large amount of value it is going away, which is also not good. However, when we are going with one limit of min plus minus 3 st, we are covering 99.7%, which means that we are practically trying to cover everybody in a certain limit, and now that is also not advisable. For example, if I want to find out that what is the average height of all the participants, it would not be realistic scientifically to say that the confidence limit or the reasonable degree of confidence with which we can I say that the limit is say 5 feet 1 inches to say 7 feet 9 inches, something of that sort. We can have a limit that doesn't make sense, because we are giving a very wide variability, very wide range, which doesn't holds a very meaningful conclusion. It is very difficult to understand. So that's why mean plus minus 2 ht is considered as a reference standard on the basis, and there is a reason more to this that will be more clear when we try to see further. So this is exactly what you will find in many statistical standard book, and also in the book of applied statistics, or even in psychiatry and mental health. The value is given. That means if a data is being taken from a normally distributed population corresponding to z, what percentage of values are there, and this will be more clear when I try to give explain in little bit more about the normal distribution and what exactly it is. So what exactly it is telling you, what exactly it is telling us, let us see little bit more. It is slightly mathematical, but I will try to explain with ease and simplicity. Now what if I say that z, to many statisticians it would be knowing that standard normal deviate, that is the statistical terminology, and in z score it's the standard terminology from anywhere. But in a purely statistical domain, in a statistical world, that z is called as standard normal deviate when we are referring to a normal distribution. So z says that we have taken a sample from a certain population, and we have a sample mean and a population mean, we divide by the sample standard deviation. Now that is what is there, that gives us the value of z. Now if we make z is 0, z 0 means that can be 0 only when sample mean and population mean combined becomes 0, their difference becomes 0. That means sample mean is equal to the population mean. That what means that z0 means that is the reference standard from where we start. So whatever sample we have taken, it totally represents that population. That is what is called as a sample. That is that z is equal to 10. What z is equal to 0 means. Now let us go one standard deviation right to the normally distributed population, and let us see. Now if z is equal to 1, it means that if z is equal to 1, it means that sample mean minus population mean is equal to 1 times the standard deviation, because z is 1. So this z value of 1 times sample standard deviation becomes sample mean minus population mean. So in other words, when you go ahead and transpose the thing, to you get the sample mean is population mean plus 1 times standard deviation. So one standard deviation ahead from the basis of population mean, that is one. That means that sample mean is 1 st away from a true population mean. That's the interpretation of the value of z is equal to 1. Now in the same way, when the value of z is equal to 2, that means we are going 2 standard deviation away from the population mean, and when z is equal to 3, we are going from 3 standard deviation. Now let us take one example. An investigator measured IQ score of 100 SLD children with a mean ST of 60.5 and 18.5. What are the estimates of three confidence limit? So we can see we can have mean plus minus 1 st, mean plus minus 2 st, mean plus minus 3 st, and we can have these three limits as 42.2, 79, 23.5 and 97.5, and 5.0 and 116. So now you see that 42 and 79 is too close. Malab, is this there? Many things neglected. 23.5 little bit wider, but mean plus minus 3 st is most wider, most variable. So that's why these are the three limits, and sometimes the whole statistical theory is based upon the concept of mean plus minus 2 st or standard error, and what exactly standard error we will be discussing in our question answer session, or if it comes. Let us tweak this example little bit more, and the same question is being reframed and attenuated in a different way, and now we are interested in finding out that what is the probability that a student selected at random will have a value higher than the mean IQ if the scores closely approximates the normal distribution. Now what does this mean? Now we know that it is been given that the IQ score of 100 SLT children, mean and ST is given, and it is being said that it closely approximates the normal distribution, and on the basis of the theory of normal distribution, we know very well, we are well informed that 50% of the value are greater than or equal to the value of mean. So the probability that a student selected at random will have a test score of IQ greater than 60.5 is 50%. In the same way, if I would have asked what is the probability, or if the question would have been what is the probability that a student selected, that instead of a student you can see a children of SLD selected at random will have a higher value than the median, then also answer remains the same. And if it is median, then also answer remains the same, because in a closely approximated normally distributed data, the mean, median and mode, they do coincide. Now, this is a little bit tricky question. The same investigator measured the IQ score with mean ST and 60 mean ST is 60.5 to 18.5. What is the probability that a student selected at random will have a value of IQ score or test score in between 60.5 and 100.5? Now, in the previous two example, what was given that the mean ST in all the three examples mean ST is given, but in that in the first two exercise, in fact the first three exercise, you didn't require to uh, you didn't require to calculate, in fact the you didn't require to calculate the value of z. However, in this example, we need to calculate the value of z. So z is the value minus mean divided by standard deviation, we get 2.16. So what does this mean? That corresponding to the mean value of 60.5, the value of z is 0. That is because z is 0. Now we have to calculate the value of z corresponding to 100.5. So when we substitute this, we get the value of 2.16. So now we need to go to the normal probability curve table, and see that approximately how much percentage of value are there in between z is equal to 0 to z is equal to 2.16. You can see the value. So how we see this, you go row wise, you go column wise this, and row wise this. So z 2.16, so you add 2.1 plus 0.06, you get 2.16. So this is 0.4846. So you can see that if we try to draw a curve on this way and represent this on a value of a so a two-dimensional scale in the terms of a curve, we can say that if this IQ score of 60.5 is distributed around an average value where z is 0, and we want to find out that what proportion of individuals are in between 60.5 to 50.5. So I have a z of 2.16, and on the basis of z equal to 2.16, my value was estimated to be 0.4846 proportion, or when we convert this value into percentage, it becomes 48.46 or 48.5 technically, if you want to round it up to a first place of decimal. So you can see that 48.46 proportion of values lies in between 60.5 and 100.5. That's the interpretation. And in fact, this is the way how different applications, different problems of theories are being formed on the basis of a normal distribution in their application. In the same question, if we are interested in finding out that approximately how much percentage of value are less than equal to 100.5, then what it will be, somebody can type in the chat box that for the same question, how many percentage of value will be less than equal to 100.5. Let me see who is typing. 0. My question is how much percentage of value? Yes, add the value of 0.50 area below. So that is there. So if you want to find out the yes, right. That means if you want to find out the proportion of individuals who are having a value less than equal to 100.5, you add 0.5 here or 50% here, and also this. So you can say that there are about 98% of individuals will have the value in the value less than equal to 100.5. The same question can be retweeted, it can be reframed in another way, that what proportion of individuals will have a value greater than 100.5. What will be the answer?
0.2% के आसपास.
Yes, 0.2%, because that is totally 100%. 100% minus 98.46%, that becomes 1.54%. In fact, so that's exactly that is exactly the 1 point that is there. So this is how we calculate. We use the normal distribution theory, and we apply. Now I am taking little bit, and we are I am going to the chat box, because after this we are moving to a more sophisticated section. There is a question that what is a Bayesian paradigm. It is a We have not talked about the Bayesian paradigm approach. However, since you have asked, in statistics there are two different approaches: a frequencist approach and a Bayesian approach. On the process of a Bayesian approach, we want to find out that if some prior information is available, how we are trying to maximize the posterior distribution of something. So if time permits, I will go into little bit more. Thanks for the compliment, and thanks. And yes, ma'am, you have rightly found, you rightly pointed out that she was a data scientist and a very good record keeper. Thank you, ma'am, for the comment. And she played a very vital role in the planning and designing of experiment. We can discuss the calculation of the last calculation of chi-square if time permits. How the scores of adherence to guidelines are calculated. I didn't follow the answer question. Can somebody who has I can request Hitesh ji to what exactly you wanted to ask.
Yes, sir. There was a slide in which you had shown that there were some scores which you calculated on the basis of adherence to the equator guidelines. You
Yeah,
had
adherence
yeah,
guidelines.
how those
Yes.
scores are calculated. I could not follow those.
In fact, there are. I haven't shared those details. It is a free website. You can go and download it from there. There are different steps to that. Okay, ma'am, regarding the principal complaint analysis, there is a totally. Thank you, ma'am, for the comments and this uh, confirmative factor analysis. Yes, it is a type of a factor analysis. I am not going into the detail. It will be discussed on 22nd. Which book? There are surprise packages. Follow the instructions. You will be able to see the video of something today in the break. It will be good. There will be some references also. uh, Hears from someone that that Excel should be avoided as a statistical tool. Yes, because there are sometimes their softwares and databases are not up to date, and sometimes we get a different result. But for the if you are using a licensed version of MS Office, that gives the true result. And many engineering applications and many other papers also use that they do recommend those part. There is a question that why we publish paper, would they expect analysis should be done by a more statistically sophisticated software? No, not at all. If frankly speaking, let me tell you that recently, last about 1 year back, I was privileged enough to join in the editorial board of an international journal, Frontiers in Public Health, and many policies that it is not important that you use any statistical software. You can use our software, you can use any HDBMA, you can use SPSS. See, that's what my point is. Rely on soft. It is not that only when we will apply a statistically sophisticated software you will get a publication. We can get publication from simple description of a statistics to some basic statistical analysis also. And we cannot even get publication on the basis of application of a data on a sophisticated software. It doesn't matter which statistical software you are using. You should be able to understand the meaning of that software and what analysis it is giving, because the major limiting factor of say SPSS, I tell you, give you an example. Suppose you want to find out the mean value of gender from SPSS, it will give you, because you will declare the variable name or a field as a gender and try to run the descriptive statistics. It will not give you error, it will give you the value. But can we take the average or the mean value of gender? No, we can't, because gender is a categorical data. That is important. So that's why understanding of data is important. Then the next question is secondary objective is a part of a primary objective? It is a part of a primary objective, because uh, what in fact in epidemiology that Dr. Ravindra Rao was explaining about the research design and also the importance of other things. So technically speaking, primary objective, it can be a secondary objective, can be a part of a primary objective. But what important it is that why we should make secondary objective. When we discuss in our department the different things and different protocols, I always advise that makes one objective as the primary objective. That is important, because if you make too many objectives, probably none of the objective will be fulfilled. And probably if you are making too many objectives, and suppose you are evaluating the research protocol of someone, and you want to find out that what is there, then what will happen? If I see that and I see six objective, personally I will straightway, there will be an apprehension in my mind that the person or the researcher doesn't know his or her hypothesis. If you are making six or a seven or a two or a six hypothesis, so the secondary objective is welcomed, is a part of a primary objective. But do not make too many secondary objective. Make objectives which are backed by a primary goal, by a primary review, which is important. uh, which software can be used to find out if the data is normally distributed or not, and how? There is a, if time permits, we can demonstrate it on SPSS. However, the name of the statistics which are there is called as Shapiro's statistics, and Smirnov test are being used. Sir, can we say that from median we can get the prediction of whole data? No, we cannot, because the basic limitation of median is that it is not regarded as the good measure of central tendency, because it is based only on 50% of the value. So if you have it is not a good measure. uh, then many people have given the right answer for the normal distribution theory, and this so can standard deviation be beyond 3 standard or to the normal distribution? It does make sense. It can be there, but however, if you are going too much of a say 6 HT or 7 HT, it doesn't mean that means your data is too much of variable, and probably we need to see that what type of data you have collected, we have collected, and how to go for it. There is a question that what for normal distribution. There was a question that probably somebody who couldn't heard. What is that question? Shapiro Wills statistics and Kolmogorov Spinoff test. In fact, 6 HD would almost cover the complete data, but what does it make sense that we need to see? So could there be question till this part? I can take it. Somebody can unmute them and they can or I can go ahead. Please don't discuss about the yesterday session. We are going to a different session. Uh, we will discuss if there if is there. If there is some comment you want to put it after solving the exercise, you can put it in the Excel by writing it. We can evaluate, and if time permits, I am fear that we will have time, but if it is still there, then we can go. Kolmogorov, yes, Kolmogorov is Spinoff test and Shapiro statistics. Any other question till this point anybody wants to ask before I go ahead to a very important topic of testing of hypothesis? Many a times, sir, data doesn't fall under a normal probability curve on SPSS. Can the data justified for with power analysis has their own limitation because power analysis is the post hoc analysis. There are different techniques to normalize the data. One can use the Z score inspect, but many a times Z score also doesn't fulfill the criteria. So we can go for a transformation of data, but all have their own demerits, which we will see. Any other question? Can we move ahead? Can we move ahead? Anybody can say yes, yes, no, or what? What do they?
Sir.
Okay.
Yes, sir.
Okay. Thank you. So now I come coming to a very important, a slightly difficult, but much important, which is forms the basic backbone of statistics and statistical theory. Now, hypothesis testing. When we talk of hypothesis testing, we used to find out different terms, different terminologies. We can say null hypothesis. We can have alternative hypothesis. What is type 1 error? What is type 2 error? What is level of significance? What is level of confidence? What is the power of the test? What is test statistic? What is degrees of freedom? What is critical region? What is one-tail test? And what is two-tail test? Now that's what makes the focus of this part of presentation, which happens to be the second last part of the presentation for this plan talk. Many a times, many people, even when I was going through my undergraduate training and in university, these terms used to fascinate, but at the same time they used to much confuse also. That what is type 1 error, what is type 2 error, what is alpha, what is beta, and still in many people sometimes it still holds confusion and light of in today's world also. But the confusion is because we interpret the things differently, because how a null hypothesis can be viewed by a statistician and how a null hypothesis can be viewed by a clinician or a mental health professional, it is totally different. A statistician will say that the sample mean is same as the population mean, whereas when a biologist or a clinician is saying, he or she will say that whether a randomly selected sample of individuals taken from a say OPD setting given with a particular treatment, whether particular treatment lowers their BPRS score or not. So that's one hypothesis. So it is how we communicate with each other that makes the things little bit confusing, but at the same time if you try to understand it becomes simple, and that what my focus is, to make at least this thing clear. So when we go when we talk of hypothesis, it is an assumption or a statement concerning one or more population which we want to verify based on hypothesis available from a sample. But what is important here to understand is that hypothesis should be backed by a certain review, and personally I feel that we don't give much emphasis to our review. That's where the problem starts. We have preconceptions in our mind, we have something in our mind, we start, we go on this, we will have this research design. Invest time in review. That is very, very important, because that is what lies the importance of review. Then formulate, and then of course the statistical hypothesis. Now, so let us go a very specific thing, and let us take this situation that there are individuals who are suffering from psychiatric condition, and there is and a pharmaceutical company or any new person want to have a formulate a new drug for the treatment of psychotic symptoms. And probably suppose that there already is a standard drug B for the same psychotic symptoms. So now the question that is very common, that will be coming in everybody's mind, that why we need drug B when already there is some drug A. The same goes also that why only Covaxin and why Covishield also, why Sputnik also? Because we need different strategies, we need different medications, we need different therapeutic regimens, because same drug, same treatment might be, that drug may be very costly. It may not be affordable. It may not be available. Sputnik is available in some other country. It is not available here. Covishield is here, not available in other countries. So there are different strategies. There are different impediments for availability of a certain drug. That's why it may be important to have a newer drug. So what would be the null hypothesis in this case? What would be the situation in reality, and what decisions are probable? We will try to see this problem in this way. Now suppose we try to extend this and see, and we make also our null hypothesis, which is always the hypothesis of null. That means there is no difference. We say that means in this particular situation, we will make the hypothesis that both medicines are equally effective in treating psychotic symptoms. That means if I am able to cure 75% of the cases with drug A, I will be able to calculate, I will be able to uh, improve the conditions of psychiatric among those individuals also about 75. Whether we are able to do that or not, that is a different issue. That is the null hypothesis. Now, but how, what will be the situation in reality? In reality, what will happen? There are different things, different factors. There are different age profile. There are different educational background. There are different, say, educational status. There are different affordability. There are different compliance. There are many. You can go on adding and adding X thousand of factors and factors in, and in any study, it is not at all possible with the best available resources and with the best time that can be available to maintain everything. So we cannot have all the factors can't be measured. So in reality, what is happening, it is that in reality what is happening is that it is beyond our control, because we create evidence on the basis of data collected on certain selected variables. We should always remember this in mind. So that's in the situation in reality. That means you can assume that in real situation, that in real situation they can have a same effect or they can have a different effect. On the same way, this is when you take a decision, you can take a decision in two ways, and we can say that new medicine is more effective than existing medicine, or new medicine is not effective than existing standard medicine. So that's the three. So these are three very important things to understand before we move forward. So there is a null hypothesis, that means both medicines are equally effective. In real world, they can have a same effect, or they may have a differential effect in treating of psychotic symptoms. When we are taking a decision, we are making a decision, remember that we are making a decision on the basis of data that we have collected. Always remember that anything, right? When Dr. Professor Pratap Sharan was giving the inaugural, after the inauguration, he was giving his first talk. He used to emphasize that any hypothesis can't be proved or disapproved, because it is null hypothesis, or the concept of statistical theory is not a type of a geometry. If you say that if all the three sides of a triangle are the same, it is an equilateral triangle, and if two sides of a triangle are same, it is an isosceles triangle. If all the three sides are different, it is a scalene triangle. It is not that. It's not that, because we make inferences on the basis of certain data that we collect, and the collection of data has its own importance, but also has its own limitation, because it depends upon in what scenario we have calculated and collected the data. That is important. So this is there. And now if we try to formulate this thing in a more in a more different way, in a more, so this can be something like this, That null hypothesis, simple, both drugs treat symptoms equally. Alternative can be of three form. Both the drugs treat symptoms differently. And now when we say that they treat the symptoms differently, we can again conceptualize this statement in two different ways, that new drug is more effective in treatment than the existing drug, or new drug is less effective in treatment than the existing drug. That's the alternative form of the same alternative hypothesis. So when we move forward and try to see in the same way, it is this. So it is there. So when it, so now this is a little bit more moving to a complex thing. I'll try to explain. So null hypothesis that both drugs treats equally, and alternative which is both drugs treats differently. So this is hypothesis, and in terms of statistical methodology or statistical theory, we write H naught and HA, or H1 and H0 and H1 to explicitly state the null hypothesis. So both drugs treat equally, and both drugs treats differently. That's our null and alternative. However, what is important is that when we are rejecting or accepting something, then we have what other contrary is this. That means when we say null hypothesis that both drugs treat equally, and if this hypothesis is true, it means that alternative hypothesis is false. In the same way, when we say both drugs treats differently, and if this H naught is false, it means that H naught is true. That is, alternative hypothesis is true, which means that both drugs treats differently. So we have to always see in respect to what we are interpreting. So once we see that null hypothesis is true, if null hypothesis is true, then alternative hypothesis has to be false, because you cannot make the same claim for the same situation. Either the both drugs will be equally or differently, but you cannot say that what is that they will be the same. But it depends upon, if your null hypothesis is true, it means that both drugs treat equally. It means that then the alternative situation becomes out of our question. In the same way, when H naught is false, we say that both drugs treat equally, and we are saying that it is false, then we are accepting the other alternative hypothesis, which is called as both drugs treats differently. So, so we have four situations in a two by two contingency table. This is only a two by two table, but all the test of significance is based on this only. Now let us see. So situation in reality is that S naught is true, S naught is false, and we can base our decision on, or we can reject or accept the hypothesis based upon the evidence collected, based on the data collected. Now, there are four possibilities. The first possibility, we go to the second and the third cell, this and this. Situation reality was that both drugs S naught was false. That means both this S naught is false. It means that both drugs have treated equally, and it is false. That means you have rejected this hypothesis, which was false. So something which was false, you rejected it. That is fine. It was something was wrong. It was wrongly framed, and you rejected it. That is fine. But on the same way, something was true and you accepted this, that is also true. That is fine. There is no error. However, when there are two things, that becomes an error. What is? We say situation in reality. That means if all the things was controlled, all things were available, and we have good data, everything was there. In real world, it was true, and we rejected it. That is an error, because S naught is true, which means that both drugs treat equally, but we have rejected this hypothesis. So, and what it will mean, it will be clear in more other situation. And the other way, when we say that when the null hypothesis was false, we accepted it. It is a second type of error. So we see that of these four possibilities, we have two error situations. Now let us see what are they. So we have just expanding that situations, those errors, into a different scenario now. The same thing, null hypothesis, both drugs treat equally. Alternative hypothesis, both drugs treat differently for the psychotic treatment. Now, these things correct. Now see the error part, the red blocks. It says that S naught is true. That means both drugs treat equally, but you rejected it. Now, what does this mean? It means that both drugs treat psychotic symptoms differently when in fact they treat equally. That's the interpretation. So, they are treating the psychotic patients equally, and you are rejecting that hypothesis. That means you are trying to make a claim that there is a difference. That is an error. In the same way, when we go to a fourth situation or the fourth quarter of this table, both drugs treat psychotic symptoms equally when in fact they treat differently. So that these are errors, and these two errors are in fact what is called as type 1 error and type 2 error. So probability, so that is again, if you see, both drugs treat psychotic symptoms differently when in fact they treat equally, and both drugs treat psychotic symptoms differently when in fact they treat equally. So that these are error. And now what does that mean? It will be more clear. There will be, I know that there will be some confusion, that but that will be clarifying in question answer and also next coming slides. So what I have done is I've took the example and extended the same thing to different scenarios under the psychotic symptoms. So now this type 1 error and type 2 error, these probabilities are called as alpha level and beta. The probability of type 1 error is called as alpha, which is significance level, and probability of type 2 error. Sometimes many people confuse that type 1 error is alpha. No, type 1 error is a situation, and the probability or the chances of committing error of that type, when we quantify that, that is what is called as the significance level. So this is probability of type 1 error is alpha, and probability of type 2 error is beta. Now, in the same way, so what exactly it means that when in fact probability of finding no difference in treatment, when in fact there is no difference, that is what is called as the confidence level. And probability of finding a difference in treatment when in fact there is a difference, that is what is the power. And that is what exactly all the research processes happens. When we try to reject the null hypothesis, that means we make a claim on the basis of data collected, that there is a difference or there is an effect. Is my sample size was sufficient powered enough to find out the real difference? Yes, it was there was reality. In reality there was a difference, and it was possible to find that difference, and that is what is called as the power of the test. That means power of the test is analogous to sensitivity of a test, sensitivity of a diagnostic test, that it helps in finding the difference in treatment when in fact there is a difference. In the same way, confidence level is specificity, and the probability of type 1 error is becomes the false positivity, and the probability of type 2 error becomes the false negativity. It always it looks confusing, it might be looking confusing, Neil, also, but always remember how we frame in our simple language the null hypothesis and the alternative hypothesis. Our interpretation goes in that way. Now let us see the three different perspective. It will be more clear in this. If we see the perspective of hypothesis testing based upon the proceeding of a court and on a medical and a statistical decision. Yesterday there was a question from some of the one of the participant, that which error is more serious, type 1 error is more serious or type 2 error is more serious. Now this will be clear in this. Let us see the situation that a court proceeding is going on, and assumption of innocence has to be made, and you pronounce the person guilty on the basis of the lack of information or the lack of the evidence. Now that is a serious error, because some person was not guilty, he was innocent, he or she was innocent, he or she did a crime, but the evidence that we gathered during the court proceeding, that was not sufficient enough to prove the assumption of innocence. Now that is a serious error. Why? Because something, when you see, that means other situation, if anybody is not innocent, that means he or she is guilty, he or she is likely to commit commit crime in subsequent period of time and might land up in the conviction or may land up in jail because of that error. Because here the risk of punishing somebody who is guilty, who was not guilty, in fact, that is more serious than other situation. That means some was guilty, but he or she was not being present. However, somebody may argue, no, sir, you can, how you were saying that, why not? Because if somebody was not innocent and he was being not convicted, he will go to the society, he will again commit crime. But his or her chances of doing the crime and coming back into the court and getting convicted in other situation because of more sufficient evidence, that can be there. But we have to minimize the more potential risk of that something who was innocent, he or she should not be made he or she should not be convicted. In the same way, when we go to a biological setting or a clinical setting, it is there. In fact, disease when disease is actually not present, but we disease was not actually present, or there was, in fact, there was no difference, and you say that there is a difference, that means there is a misdiagnosis. And that means when a disease was actually not present, but you said that disease is present, that means we are misdiagnosing the case, we are making them false positive. In that way, that is an error. In the same way, in the actual situation, when the disease was present, but we didn't label them as disease absent, this becomes a misdiagnosis. So that's our two errors. So and in statistical perspective, they are called as type 1 error and type 2 error. So what exactly is the definition of p-value? There are different definitions. Simple definition: p-value is calculated from the data indicating the likelihood that an effect. Now here, this thing is very important. Effect. How we are defining effect? Are we defining effect in terms of a specific reduction in the scale of Hamilton anxiety rating scale, or on a BPRS scale, or we are just saying 50% of the individual will improve by one drug and 50% of the individual will be improved by second drug? Now that is effect. We can have different effects. And then, so hence, smaller the p-value, higher the likelihood that the observed effect is real rather than one due to chance or sampling error. Or p-value measures the strength of evidence by indicating the probability that observation at least as extreme as that observed would occur by chance. So that means we do not want that whatever effect, whatever difference we got only due to chance. There should be a real effect. Now, when we say a real effect, we do not want to have its higher probability, because higher the probability of p, more the p value, it means that we are not sufficiently guarded. We don't have strong evidence in support or in rejecting that hypothesis, and therefore we will have to accept that hypothesis. So, smaller the error, we have smaller the role of chance given the hypothesis is true. So that's why it measures the association, it measures the evidence by indicating the probability that observation at least as extreme as that observed would occur by chance. So let us take one very I will try to explain this thing with a very simple illustration. Now suppose we are sitting in a room, so four or five people are sitting, and that room has a window which a glass over it, and that glass is broken. Now there can be different questions, different scenarios that somebody will argue, and suppose the heated argument goes in that way: what was the cause of broken window, who broke it, how broke it, when it was broken, what instrument was used to break that, uh, whether some child, well, there can be n number of questions that can be asked among ourselves. But if you talk to a statistician, he or she will ask only one question: that when that glass window was broken, somebody else outside of the room should not have hit at the same time. That means the chance factor, that probability should have been very less, or either zero. Now that's what is the concept of a real effect. That means somebody hitting from inside the room and somebody hitting from outside the room should not coincide. That means there should be a real effect. Now that is what we are trying to always find, the real effect in that situation. Report the p-value calculated from data. Likelihood, so here likelihood of observing the observed or more extreme by chance. Smaller the p-value, the lesser the role of chance, and smaller the p-value, higher the likelihood of a real effect. Now there is a there is another concept what is called as confidence interval. Now it is also little bit confusing, but I will try to illustrate with an example. Now suppose I want to find out that on average what is the at what time the participants of this registered workshop have joined in through the Zoom. So I have a 4-day data because this is the fifth day, and I plotted that graph from something, and the graph something looks like to be this. So some people started joined at 3, somebody may join at 3:30, somebody will join at 4, somebody will join at 4:30, and in the same way it will go. Now this is higher because we see that more or less many people join at this time, and the peak is at 6 because it may be that many of people who would have left the office by 5:30 or 6 or would have reached home, they would have got chance to join. So this is the distribution. So the 4-day data said that this is how we can model. Now what exactly, now how, why we do that? So we analyzed the pattern of some participants, and we found out that the average joining time is 3 p.m. So why we are doing this exercise? Because we want to know that as an organizers, when we should initiate Zoom sessions. Should we initiate by 2:30? We should initiate by 2:45, or we should initiate by 3 p.m. or 3:15 p.m. What should be the time? So suppose we say that on average our point estimate is 3 p.m., that we initiate the discussion, we initiate the meeting. Then there would be some individuals who would be joining at 2:45, and there would be reasonable person who will also be joining at some other point, that is at 3:15 p.m. Now if we try to see this on a linear scale, it looks to be something like this. That is the lower limit. That's why we started giving the link migrated in as 2:45 p.m. so that you can have in a waiting and go for, because somebody will start joining the sessions. On average everybody will try to be there at 3 p.m. because the workshop is scheduled at 3 p.m. to initiate the sessions, and 3 p.m. is the upper limit. So now 2:45, 3 and 3:15, it becomes the lower limit, point average or the point estimate, and the upper limit. And when we try to see, this becomes the 95% confidence interval. Now what does this mean? This means that out of 100 individuals, about 95 individuals of them would be joining the Zoom session in between 2:45 p.m. and 3:15 p.m. So it is everything in data is more how you analyze and how you interpret. If I would have said that the 95% confidence interval when estimated from the data, it is 2:45 p.m. to 3:15 p.m. with a point estimate or an average of 3 p.m., it doesn't mean any sense. What does it mean? It means that if 100 people's we have to do this session on 100 individuals, when we are 95% confident that about 95 people out of that 100 will be joining our session in between 2:45 p.m. and 3:15 p.m. So that's the interpretation of this. Before moving forward, I should take some uh, uh, questions. I think if it is there, please do elaborate on data transformation. Data transformation can be different ways. If time permits, I will, for example, I will try to demonstrate. The best transformation is that you calculate the Z score of all the individuals. Now that we will try to see and demonstrate. We always state in terms of hypothesis rejected or accepted. Why don't we say hypothesis accepted or not accepted? Because we can't it is something like the same approve or disapprove, because we are limited on the basis of statistical theory by making the sense that we are not everything can't be calculated, everything can't be gathered, we can't gather information on everything every time. That's why we say that hypothesis we can reject or we cannot reject it. Accept null hypothesis and fail to accept null hypothesis would be two inferences. uh, Accept null hypothesis and failed to I don't understand the question. Can the person who is typed can unmute and ask what he or she what he wants to ask?
Sir, just I'm asking how to calculate the confidential interval.
Confidence interval.
Yes, sir.
We will be demonstrating it in Excel.
Okay, thank you, sir.
Okay. In yesterday exercise of chi-squared, how to calculate p-value. In fact, I deliberately stopped that because many of you said that it is a simple example, we can do it, but if time permits, we will see. How to calculate confidence interval. No, in fact, it is fine. Somebody asked one question that accept null hypothesis and failed to accept null hypothesis would be two inferences. What is the what he wants to ask? Matlab, I didn't get more clarity on the question. Is the person here? So I'm not getting. Hello. No. Sir, is 95% confidence interval a standard value or it can be different? 95% confidence interval is in fact, technically not a standard value. It is, you can say, it is an interval estimate of some parameter statistic, and that we want to give that uh, just same example that I gave. If I try to explain this in more clarity, that it is not a standard value. First of all, it is not a value. It is a range. That's one difference, and it gives us an interval type of a thing because it tells us, like if I take that example that was being discussed yesterday, that what was the odds of having liver cancer among those individuals who were alcohol users. So I result that the result came to be 1.23. So we said that 1.23 times higher or 23% higher. Now, statistically, in statistics, we always deal with variance, with the error. That's what the beauty of statistics is, because it is because if everything is constant, there is no role of statistics. If the if the age of all of the participants was constant, we will get the same value. That doesn't make sense because statistics always deal with a variability or a variance. Now, any estimate in statistical theory, always remember, it doesn't have any significance, any value, if we don't give the error, that is the standard error or the standard deviation. uh, there is a difference between standard deviation and standard error that we will discuss during our practical session. So in fact, it is not a standard value, it is a range that gives the likelihood that how much we are confident that our estimate lies in that limit. So when we say that there is 23% more risk of greater risk, or yeah, 23% more risk for individuals of so alcohol users for developing liver cancer, alcohol users for developing cancer, then what is the CI? That means on average the risk is 23%. That what is the lower limit and what is the upper limit, that is important. So it means that probably if we estimate this, then we will get say something 14% and 36%. So it be something like that. On average 23% risk is there, and which will likely to vary in 95% of individuals in the range of 14 to 27, which means that if we do the same experiment 100 times with same condition, then 95 times our estimated risk will fall in the limit of 14% to 34% or 27%. That's the interpretation of a value. Thank you. Sir, how much real effect can strenuous and error variance have on our hypothesis? Many times you are not able to control and minimize them. In such condition, how should we justify our results? Very nice question. In fact, that's what the purpose of regression or analysis of covariance or analysis of variance that all did. Uh, Error variance, the basic assumption, in fact, I will respond to this question and we will be responding more on correlation and regression. It depends upon what type of thing you are trying to assess. Now, suppose if I take the same example of, I will be frequently now taking the example of BPRS, psychiatric symptoms and registered participants to make the thing more clear. Now, like we know that we got the registrations of 654 individuals, but only about 450 people joined on the first day, and over a period of time for fifth day, on average we are getting a attendance of 150 individuals. So what is the reason that about 450 individuals didn't got that didn't register? They registered themselves but they didn't attended it. There can be different reasons. One difference, the most common reason can be Sir, there is a network issue, understandable. There is a myopicity, understandable. There are many things you can't control because there are different factors that we are trying to study. There can be n number of factors that limits that make it impossible for individuals to join. That's the deal. So the how much real effect can straightness and error variance have our hypothesis? They can have a much impact on our real effect, and maybe that's why we say that the real power analysis or the real sample size should be large or reasonably large enough to have some meaningful interpretation, because the common assumption in error or other things is that, or in a regression analysis is that the error should be randomly distributed. Now what does that randomly distributed, that will be more clarified when we try to take the correlation and regression exercise, correlation regression for tomorrow. Can I move forward? Any other question? I have addressed all the questions, in fact. Okay, thank you. So that's what. Now there are, once we have collected the data, there are different things, different assumptions. So that's what we make. Now I am coming to the actual interpretation of the result. Now I am hereby we assume that we know what is our null hypothesis, what we are rejected hypothesis. We have the data and we analyze the data and we are doing something. So these are the steps in hypothesis setting. We evaluate, we review, state, and this select test statistic. Now that is what is important. Determine the distribution of test statistic. There what the question of the error variance and other residuals come into play, that how we are appropriating choosing that, and we take some decision rule, we calculate the test statistic, and then we make decision on the basis of the analysis that we got. So what exactly is that statistic? Many of people who had published many papers, you would have seen something like 1.96, 2.58, 3.25, something of that value. Now what those values think? Now these values are, say, these are the critical values. Now it says that if you calculate your value on the basis of the data collected and your value is greater than that value, it means that it is falling in the region of rejection. That means it is falling in the region of rejection of null hypothesis, and you are getting a positive result, which means you are rejecting the null hypothesis, and you are saying that really there is a difference, and that means alternative hypothesis is accepted. That means there is a difference, and we are showing that there is a positive effect. However, if that value is less than 29.5, then it is falling in the acceptance region. That means the data collected or the evidence gathered is not sufficient enough to to reject the hypothesis, to reject the null hypothesis, and hence we will be accepting that hypothesis. Now it is something like relevant statistics minus the hypothesis parameter and the standard error of estimate. Now this is a very simple non-mathematical equation. It is the equation, but it is I am not using any equation in this. If we try to conceptualize this same equation with the what we discussed in the normal distribution, x minus mu by sigma, it is something like this. The only difference is in the denominator, that in place of standard deviation we have standard error. Now I will be explaining that what exactly is the standard error. Now critical region, many a times what is the what I in the previous slide I said critical region and the acceptance regions is there. What are they? So the critical region is represented by a portion of the area under the probability curve of the sampling distribution of test statistic. So null hypothesis can that sample mean is same as the population mean, and the alternative hypothesis is mean that sample mean is not not equal to population mean. So it is something like this. Now many a times when you read the table, you will find under the statistical analysis section it is written that the two-sided p-value less than 0.05 was considered to be significant, and the data was analyzed through a licensed SPSS software 25.0 or 26.0%. Now what does two-sided p means? The two-sided p means 2.5 values, 2.5% of values are ranked to the right hand side, and 2.5% values are ranked to the left hand side. You add up and that becomes 5%. So when you say 5% two-sided, it means that the software is looking for these scenarios and calculating the p-value on the, but the back side is this, so that you can say that this is the upper critical value and this is the low upper critical value and the lower critical value. In statistical notation they are called as z alpha. So when we make our hypothesis direct, you need a, when we make our hypothesis in this way, that the sample mean is same as the population mean as the null, but alternative that sample is different, is not the same as the population mean, then at the low significance we are going a one tail test, that we are going to the right hand side. That means we are interested in the right hand side, we are interested in the right hand side of this area. That means it is this. When we are making this a left tail test in terms of this, that, and we make the alternative that the sample mean is less than the population, it means going to the left hand side. So you can see that when we are going two sided it is 0.025 and 0.025, but when we are going to the right or a left it is adding up because we are going only to one side. Thus critical region of 5 of z for a one tail test left or right at the significance level alpha is same as the critical region of z for a two tail test at the significance level 2 alpha. So now what exactly or what does this mean? Now this will be more clear. If you want to find out above what z score do 5% of the cases fall. So it is this level of significance two tail set single tail. If you see 1.965% two tail, 1.96, and then it is 1.645 for single tail, and 1.645 single tail is same as 10% for two tail as 1.645. In the same way single tail 1.28 for 10 is same as two tail 20% 1.28. So what exactly that means? If you want to see the value of a significance, that means the critical region or a critical value, then what happens, you have to see that how you have framed your null hypothesis. Null hypothesis is always non-directional, that is it is starts from a zero, whereas the alternative hypothesis is may be or may not be directional. So when it is not directional it is two-sided, but when it is directional it goes something like this, that above what z score do 5% of the cases fall. So it is this, you say you go to the right hand side, I am saying for 1%. So what is, I will see the one tail tell, and I see for I see it is one. So it is asked what is 5% of cases fall. So for 5% level of significance my critical value is 1.645. So this is my critical value, which means that at the critical value of 1.644, the 5% of the values will be towards the right hand side of this. In the same way, if you above what z score above what z score do 1% of the cases fall, and you will see that one cases fall below what z score, you can say if I have to go for below, that means single tail 1%, that is 2.33. So it is left hand side, so it will be negative. And between what to z score do 95% of the cases fall, it becomes plus minus 1.96, which is 95% confidence interval. This is 1.96. And if you want to calculate between what to z score do 95% of the cases fall, it will be 2.58, 2.58. uh, so we are in fact I will be taking the question, but I am closing the this one because one part is left. I think I should demonstrate it before the actual classes is there, because that is what the real testing of the data involvement will be there and we will be taking. So let me go to the chat, and there are some questions. Let me see that, and you all can unmute yourself and ask. Sir, when to use one tail test? Very good question. One tail test is usually made in case of a clinical scenario, clinical sense, when we want to make some new drug, make some, because we want to go some direction. We want to say whether there will be some difference in the treatment. We go to the positive side, we go to the negative side. So that's why null in fact, if you ask statistically, it is always advisable on a statistical premise to make two-sided hypothesis, because that you will be safer. Because to make one-sided tail test, you have to do a very solid review and a very solid evidence to make that, and you require a large resources and probably large number of patients to address that hypothesis. uh, how should we decide level of significance? Level of significance is a prefixed entity, like 5% level of significance, which is the probability of type 1 error. And that's why we say that now there is a history of this 5%. Now what how it was that many of us statisticians would be knowing, and even the non-statistical audience would be knowing. The history goes like this: that R.A. Fisher was doing an experiment in his setting, and he wanted some agriculture experiment, and he was yielding the the yield of a crop in a certain design of experiment. Now there was a very the common question that came to his logic in his mind was that there can be many factors that can govern the yield of a crop. They might be the fertilizers used, they might be the amount of insecticides or pesticide used, it might also be the say your rain, your atmosphere, your weather conditions, the quality of seeds. There can be different factors. He applied his experiment in a real world in different scenarios, taking the source of variation for all these different factors, and he and what was his result? That he got the same result. He got the same result, and his result deviated only once when he did the experiment 20 times. That's why he said that 1 by 20 that becomes 0.05. That's for the standard. But many people also say that is always 5% is always 5% the usual convention. uh, it is not in fact always the convention, because uh, if you if you try to if you try to see the if we try to understand, if you see some papers in the field of applied biostatistics or bioinformatics, you will see that the p-value may be also be written as 2.5 into 10 to the power minus 6 or minus 7. There the level of significance has already gone down. So the convention of 5% was there, but it is not it is much more stricter now in today's sense. And that's why you will find in many, say if you go to International Journal of Epidemiology or bioinformatics or cell biology or in other papers in the field of biological sciences, which are high-end journals, you will see that you will get reporting of p-values at 2.5 into 10 to the power minus 5 or minus 6. Now that is also possible. Let me see if there are some other questions. Sir, how can we know or test whether we are making type 1 or type 2 error? There are no situations that these are the statistical philosophical understanding, and on the basis of the results obtained, data collected, we make those assumptions. Now, when you report your analysis that what is the power of your test, and if you say that the power is say 75%, there it means your type 2 error is 25%, because power is 1 minus beta, that is the 1 minus the probability of type 2 error. So already we are able to calculate that what is there. Hopefully that addresses the question. Anything anybody wants to ask any question? I think I have answered all the question. I have tried to answer all the questions. Anybody would want to unmute themselves and ask some question?
Sir, I think Shashank Tripathi had asked that question about the hypothesis testing, and then
Can you be little, ma'am? I'm not able to listen. Yes, ma'am.
sir, I think Mr. Shashank Tripathi had asked that question about hypothesis, or maybe currently he is not here, which you wanted to answer, but the person was
Shashank
not
has
there.
typed a message. I will request Shashank ji to unmute and ask the question. Shashank.
Sorry, I think maybe he's not here at the moment, but he was the one who was asking when you wanted to
Yes, in
explain.
fact, he has commented that type 1 error series is a universal statement in nature for every hypothesis. Yes, it is there. Anybody else would like to ask something? I think, is it mandatory to calculate power in sample size calculation? In sample size calculation, yeah, in sample size calculation, it is important to consider the power of the test, because well, in fact, well, of sample size calculation, when we try to find out, there are different ways. Broadly, there are two ways: testing of hypothesis, estimation, and testing. So when we are trying to estimate, their power is not required, but when we are going for hypothesis testing, power is there, because the definition of power is that probability of finding the difference when in fact there is a difference. That's the power. Now, so whatever sample we collect, whatever sample size we determine, it is based on a specific power, and the usual convention and the statistical theory recommends that that uh, that at least the power of 75% and above is there, is acceptable. Yes, there are specific statistics and formula for testing power. We haven't planned in our schedule, because for 9 days it was not possible to cover everything. That's why there. Shashank ji is typing. I asked about type 1 and type 2 concept in diagnostic tools. Sir has. Thank you for the compliment, Shashank ji. Thank you.
Thank you.
Thank you. Any specific question? So we can take a 15 minutes break now, and we will be playing some video. But still, I say, before we take a break, somebody wants to ask anything, feel free to ask, because that is a heavy dose. Too much information, I know. For something, some would be a little bit clarified. Maybe many of you would be a little bit more confused. But I have tried my
Just
level best.
so just a small thing I was not clear about, sir, that the table that you had shown the of the Z values of one-tailed and two-tailed, how are the values related, sir? Like, do they have some pattern? In
Yes,
one of the slides,
yeah,
sir,
I
you
am
had a table.
addressing, telling.
Ji, ji.
Yes, we have a hands-on session. Sir, if in fact, Hitesh ji, any reference for power calculation? We haven't planned a statistical. Please have a little bit more of a patience. What we will be demonstrating in the video, we will be referencing some books and other standard, that we will be. It will be more clear how we go for it.
Okay, sir. Thank you, sir.
We don't, time doesn't permit us to go about the sample size calculation, and we haven't planned, because it was not possible for us. So frankly speaking, I take my apologize for that, for not planning, because time doesn't permitted me to plan for sample size selection study. Regarding the question of a two-tailed and a one-tailed, what I somebody asked, that when we are going to a when we go to the when we are addressing, when we make our null hypothesis, we always make an in a non-directional fashion, that we say that there is no difference. However, we can make our alternative hypothesis either directionally or non-directionally. So we can make the hypothesis in this way, that both the treatments are not equal, or alternatively, we can also make the alternative hypothesis that both the treatments are one treatment is better than the other treatment, or the one treatment is inferior than the other treatment. I am again getting questions and questions from sample size estimation. We have not planned this session. Let us please be a little bit considerate towards us also on this organization. However, you have asked, so I have said that for the sam, because for let me answer the one question, then I will take up when I will take up this question, that for when we make an alternative hypothesis two-sided at a 5%, which means that 2.5% can be to the left hand side and 2.5% will be to the right hand side. However, when we are making one-sided, then we will have to make both the things to either they will be towards the right side or they will be towards the left side. So if we have fixed our level of significance at 5% and we want to make it a one-sided, it goes 5 plus 5, it becomes 10% if we are making it either to the right hand side or to the left hand side. It is the sum of the total probabilities that is what is required.
Sir,
Hopefully that addresses the
the
question.
theory is clear, sir. I was just wondering whether there was a relation in the Z values that you given in a table.
Yes, there is a relation in the Z value. The 1.64 becomes positive towards the right hand side. Z is equal to minus 1.64 becomes towards the left hand side. In this way, for 95% plus 1.96 will be towards the right hand side and minus 1.96 will be towards the left hand side.
Um, so can you just show that slide once? Then I can probably. Chalo, it's okay. Sir, I'll go through it later.
Now I am taking a break. And after that, there would be some more questions. I can take that. So we take a break of 10 minutes and we will start at around about 5:20. अमित जी, मैं स्क्रीन नहीं शेयर कर पा रहा हूँ। आ रहा है कि होस्ट डिसेबल्ड पार्टिसिपेंट्स स्क्रीन शेयरिंग। एनी टेक्स्ट पे लेना है क्या? तो ये पता नहीं शेयर क्यों नहीं हो रहा है। हाँ, Welcome back. Apologies because there was some technical glitch which we were able to resolve. We were resolving. That's why it took time to get back. I hope all the audience are online now. We can start.
Yes, sir.
Thank you.
Yes, sir.
So there was a question from someone regarding the area and the other thing. It is this. So
जी
it
जी
is
सर जी सर सर आई वांटेड टू आस्क कि ये जो टेबल है इसमें सर सम ऑफ द वैल्यूज आर लाइक गेटिंग रिपीटेड एग्जैक्टली सो व्हाट इज
वही
द
वही
रिलेशन
वही
द वैल्यूज
repetition. That's the reason what I explained,
जी
that
जी
when you have to see for a two-sided,
जी
you have to see for a single-tailed at 1 5% level of significance, which is 1.645. So when you will see for a two-tailed, it will be 1.645. So it is for two-tailed, it is 1.64. So 5%, if 5% for single tail is 1.645, that means you are going to the right hand side or you are going to the left hand side. So 5% plus 5% becomes 10%. So the single tail value of 5% of 1645 will be the same as at the level of significance for 10% as 1.645. Similarly, for 1.28 value, which is for the single tail at 10%, when you are going to the either right or to the left, you add up, that becomes 20%. So again, that value will be the same, which is 1.28. I think hope it's clear now.
जी सर आई गॉट इट थैंक यू सो मच सर फॉर
Thank you.
गोइंग बैक टू द स्लाइड इट्स क्लियर नाउ
Okay. So now we come to the statistical test. When we try to do some statistical test, there are different types of statistical assumptions. There are many assumptions, and we can't go into each and every detailed assumptions, but there certain assumptions are very important to understand. We will be taking some questions which are remaining in the chat after this presentation. Uh, so like if we have a one sample situation or we have a two sample situation, we go for a small or a large sample size. We have to know about the population distribution, and we have to know about the population variance, which is known or unknown, and a small or a large sample size or a population distribution, known unknown population, on the basis of a two sample also. Now if we are dealing with a one sample problem, so if I want to find out whether the mean score of brief obtained on brief psychiatric rating scale among patients treated for psychotic disorder is same as the population from which they are taken or not. Suppose you are planning an MD thesis dissertation work, and you want to use the patients of psychiatric disorders with a certain psychotic disorders, and you want to apply, but you want to replicate that result to the entire population of your hospital setting, from which, so you will be taking a sample. So whatever sample you take, whether that sample, so whatever mean estimate score of BPRS you obtained on the basis of your sample, whether that reflects the true population mean of your hospital setting or not, that will be a one sample situation. Now if we generalize the same problem and we want to find out that there can be a differential effect of gender may have a role to play, and it might be possible that we need to do the comparabilities of scores of BPRS across the gender. So you will estimate the average of BPRS score among male and average BPRS score for the female. So that becomes a two sample problem. Now when you assess the total, that means either you are using a 18 item BPRS or a 24 item BPRS. If you are using an 18 item BPRS scale, then the range of all each of the items are given from 1 to 7. So you can have a total range of 7 to or from 18 to 126. That becomes so you can have a baseline value. After 2 years you can reassess them. That becomes the paired data. So that's an extension from a two sample to a paired sample. In the paired sample, the same individuals are repeated. So that becomes the paired sample. For a longitudinal sample, for a one-way repeated, you can have individuals. You can record their BPRS score at baseline. We can record their scores at the first follow-up, say after 2 years, or we can also record their scores at the second follow-up. So that is not paired, but it is an extension of a paired, and it becomes a longitudinal sample. So in this case we say a one-way repeated ANOVA. Now Now here the complication starts little bit more, and you want to find out that BPRS total score might be also affected by different duration treatment, say by 1 year or 2 year or 3 year, and your hypothesis may be that those individuals who are having, so your null hypothesis in this situation will be that the mean PPRS scores of individuals who took the treatment for 1 year, mean PPRS scores of individuals who took the treatment for 2 years, and the mean of the BPRS scores across individuals who took the duration for 3 years of treatment, or those who were under the treatment in a hospital setting for 3 years, their value is the same. Now that is a multivariable problem. Multivariable problem because you are adding more than two, that becomes a multivariable. So in the same way, yeah, again you can have one more variable, that even you can have a differences across the duration of treatment, and you can also have differences across the gender. So you can have a two-way problem here, that becomes the two-way ANOVA problem, because the source of variation, analysis of variance is source of variation. So variation across the treatment and variation across the gender, and then you have the BPRS scope. So that is a multivariable problem. You can go on increasing this problem in the same way, like this, that becomes a multivariate testing, because you can have individuals, you can have in fact I should not have written gender here, it should have been different, it should have been, say, duration of treatment 1 year or 2 year or 3 year, and then it will be a BPRS total score of for first year for 2 year. Or it can be more complicated, that we can add another variable of, say, assist alcohol, who are in the low risk or moderate risk or high or hazardous risk on the basis of alcohol assist questionnaire, and then you can measure their BPRS score at 18 and 12. So here the sources of variation would be time, that is 1 year and 2 year, which is repeated, and it could also because of the different variable, because of alcohol which is being tested at three different levels. So that becomes the multivariate testing. Much of our parametric test or any choice of test depends upon what type of data we have. So once you have a data and the assumption of normality and homogeneity is being addressed, when you have a single sample, we go for a one sample t-test. When we have two groups, we go for a two independent sample t-test. When we have unpaired data and we have two groups, we go for a two independent sample t-test. But when we have unpaired, when we have three or more groups, we go for one-way analysis of variance with post hoc test. Now post hoc test means, like the previous example when I gave you, that duration of treatment you wanted to find for the total BPRS score in a, say, one way ANOVA would be something like this. In the one way ANOVA, that means duration of treatment for 1 year, 2 year, 3 year. You did the one way ANOVA, you got the test, but you want to find out whether one and two, what is the test of significance difference between one and two, what is the difference between two and three, and then you have between two and three. So that is a post hoc test. That means post hoc means you are doing something after something has been done. That is what is post hoc. It has its own limitation that if time permits we will discuss. On the same way, when we have a paired data, we go for a paired sample t-test. When we have a longitudinal data, separate session of longitudinal data analysis, we are devoting it further. So we will be discussing in more detail tomorrow. So when we have a one group, we go for a one-way repeated ANOVA with, sorry, when we go one group, one give with one way repeated ANOVA with post hoc test, and we have two or more groups, we go with a two or a three-way repeated ANOVA with post hoc test with analysis of covariance and multivariate analysis of variance on the basis of the test. In the same way, when we can go on the under the non-parametric family, when we have a small sample size, it is unpaired, it is two groups, we do a Mann-Whitney U test. If it is unpaired, three or more groups, we do Kruskal-Wallis test. When it is paired, we do a Wilcoxon sign test, and we have, when we have three or more, we do a Friedman test. Now these tests are not at all totally exhaustive, total list of tests, but these are the basic tests that is required in any application, whether we are any field, whether we are working in the field of a mental health or we are working in the field of, say, any branch of science. These are the basic statistical tests. All the tests above them, above these list becomes more complicated in nature. They becomes more sophisticated in interpretation, for which sound understanding of statistical theory as well as database management and also the handling of softwares is required. So let me take some question if I can take. There was a question. I think I have rejoined the meeting, so old chats are not available with me. So in fact, there was a question of sample size determination. Question is being sample size. Sample size is again and again being asked. I apologetically said that we have not planned sample size. Uh, the in group, I will request someone to probably, if they would have seen, they can put a link. If it is there, if they can be seen. There was a question, if I can recall, that whether you all have to submit the assignment of practice and exercise both. I think if you are in a condition to submit both, it is welcome. But at least your exercise, what you've been given, that I think for today, if that is the question, then for today only you will try to demonstrate, if time permits and we are able to finish all the exercise, you can practice along with me. And when I will be explaining upon multivariate and multivariable tomorrow in the regression analysis, because we have a devoted session to that, and that comes under regression. That's why I am not doing there. Sir, there is no test similar to a two-way repeated measure in case of a non-parametric test. It is not available, at least to my knowledge. I also tried to see many times, but I couldn't. If I couldn't get it, I tried many times. If you can get it, then please do let me know. But to my knowledge, it is not there. Then there is a question that if assumption is not fulfilled by data, then we can take log and check those assumptions again to use parametric test, as these are better. Always remember what are the demerits of. Thank you, Victor, for sharing the sample size calculator. Um, uh, for Always remember, whenever we do the major limitation of a non-parametric test is that the major limitation of a non-parametric test is that it transforms your original data. So now suppose if you have a, say, a value of, say, 25 or 20 or 29 or 31, and you take the value of log, it can, your fragment test is if you transform the data on the logarithmic scale or for other scales, what it will happen, uh, that you will be in fact in fact, for the Friedman test is used for a one-way repeated ANOVA for a non-parametric. Yes, what I was saying was, for a non-parametric test, it is not possible to. It is what happens in non-parametric test. All the values are converted into a different value. So I will request somebody to mute themselves, please. If somebody is unmuted. In fact, that's why since it changes the original form of a data, it is difficult to interpret the thing. It would be something like, you measure the hemoglobin level in the range of 10 to 15, and you transform it and you interpret it. That's there. So what I advise in that way, that you treat the data as in the original form, but you apply the non-parametric test of analysis and report the p-value on the basis of non-parametric test of analysis, the test of significance, with a caveat that the data didn't follow the normal distribution. However, to remain the original form of the data intact, we are reporting on the basis of mean standard deviation or median and interquartile range. However, the test of significance has been applied in the non parametric form. Uh, Sir, how do we know if the data is paired or unpaired? It depends upon how data you have collected it. If you are taking one observation at one time, and on all the individuals you are taking the observation again, that becomes a paired data. Why the repeated measure in is known general linear model test? General linear model test, it is known because all the family of regression analysis, either repeated or in one way or two way, J falls under the domain of a regression analysis. They all form under the they all go under the domain of regression analysis, which are a linear models, because linear models, because we say y is equal to a plus bx, or the simple linear regression, and all the analysis of regression what we test, either we do extension of from ANOVA to two-way ANOVA, three-way ANOVA, n-way ANOVA, or MANOVA, or analysis of covariance, all are taken from all are taken in that way to under the family of regression analysis. So that's why it is called as a general linear model test, because it is embedded under that particular the family, it becomes the general linear model. That's why even after taking logarithm of variables with autocorrelation still remains how to overcome it. If their autocorrelation still overcomes it, probably you are talking of time series analysis, which we are not dealing with time series analysis. There are different smoothing curves based upon different statistical techniques that can be that takes care for that. There was a question, probably if I can recall, that median, about median and something. What was the exact question? I do not know, but if I can recall it correctly, the question was that probably that why median in case of a skewed data, why median should be reported. Yes, when we are talking of a median, we are reporting the descriptive statistics of a skewed data on the basis of a median and interquartile range. We cannot that's why I say we cannot generalize on the basis of median, because median is based only on 50% of the values. It is not taking other in consideration according to other 50% of the values. And if you go to the basic textbook of statistical theory, according to Euler's criteria in the under the chapter of measures of central tendency, it is very specifically given that mean is the best measure of central tendency, because it is based upon all the observation. That's why it and that takes into account for the estimation of standard deviation and standard error. That's why we cannot generalize the result on the basis of a of median. So could there be any other question on this? The question of if assumption is not fulfilled by the data, then can we take log and check those assumptions again to use parametric tests, as these are better? In fact, it is in my understanding, it is sometimes even if you take a Z score and even if you take the logarithmic, it might be possible that the data will not follow the normal distribution. So even the transformation doesn't always gives us the flexibility to normalize the data completely and use the appropriate test. Yes, you are right that parametric tests are always better because they take the original form of the data. But that's why we all, as a statistician and also as the research methodologist, we should always try to visualize that transformation of data is the last resort. We need to see the data and take the data in the usual form. Practically, my habit as a theoretical statistician, whenever I work, I always advise that use the data as it is and report the descriptive statistics on the basic form of the data, but do the test of significance appropriately depending upon the fulfillment or violation of the statistical assumptions. Auto-correlation or other things. Atulji, can you frame the question what you were trying to ask? Hello, Atulji, can you please unmute yourself and ask the question?
Uh, Hi, sir. Hello.
Yes, sir. Hello.
While calculating regression analysis for dependent and independent variables, is it necessary to measure autocorrelation using Durbin-Watson? And if it is not feasible, then how to proceed? That I face one problem.
In fact, in regression analysis, the most important assumption, there are four important assumptions: homogeneity, linearity, and normality, and independence of record. So it might be possible that or might be possible that autocorrelation is not being overcome, because if you try to extend the problem from this say a simple to a multiple, what happens when we are when we are doing a regression analysis, parametric and a non-parametric, either in in a continuous form, what will happen that it might be possible that there are different sources of variation. It might be possible that in your condition, a continuous variable maybe some of the outlier will be there. If the outlier is there, then we should remove that record. Even after removal of outlier, it is not possible. Then the best method to do is do not do a linear regression analysis, but do a curvilinear regression analysis. With all the strategies of statistical modeling and regression approaches, if it is not possible to establish the linear association between a considered dependent variable and the independent variable, it is always advisable to go for a say curvilinear type of relationship and model the relationship on the basis of a non-linear transformation, say a variable or an exponential or a J-shaped curve or a shape. It depends upon when we see to try to see a scatter diagram or a scatter matrix. It gives us an idea that what best form of regression analysis or a best form of statistics can make that curve to happen.
Thanks, sir. Thank
Thank
you.
you. There is a question that how to work probability of integral transformation. I didn't get the question. Can you please explain the question, Manoj ji? Okay, we will connect something. So that finishes the first part, and almost I think it is almost six now. No issue. Uh, there is a now we have planned a practical session for that. Are you people able to download all the one Excel file for the practice session? Can anybody write the values of the first record? Just type it in the chat box, the name of the variables and the value of the, yes, it is quantitative data analysis. I just want to ensure that everybody has the same file. Otherwise, I have already attached that file in the quantitative of this in the chat. Record bprs i1, bprs i2, this, yes, fine. And can we have the first record values? If I can get some comma or space in between, that will be more clear to me. No, 37530 is not the correct file. The value should be in between 18 to 126. So that would be the correct file. So if somebody has the older version, because you needed to revise that file, so we uploaded it after I think 9 p.m. today, 9 a.m. today. That's why. Yeah, 92. That is fine. So if everybody is getting the first record as above 18 or less than equal to 126, they have got the correct file. Okay. So can we move ahead with the demonstration? No, 86, it is 8677 or 86,77. Okay. Okay. Then it is fine. Yeah. Yes, fine. So I think many of you have already got the correct file. So I am trying to demonstrate, if possible. Yes, fine, Victor. If file is fine. I am trying to demonstrate, and I will try to finish in about 1 hour. About few exercises that I think that is possible to be done even in Excel, and then I will try to finish it, and I will be slow and trying to demonstrate each step slowly, so that many of you could get it, and you will be able to practice. So what will happen, you will find probably two exercises. One would be in the material, one will be your submission page of the today's date. So you need to upload only the exercise file, and you can use now, I think I did plan to work in R, but I don't think that it will allow me to, time doesn't permit me to get to R. So I will see tomorrow that if when Dr. Vivek starts taking the session, if he can demonstrate, or if time permits, because for tomorrow we have 3 sessions, so they are different. So in fact 2 sessions are there, so we will see that probably R would be, we can take up there. So that is there. So can I start demonstrating on the Excel? Is it fine?
Yes, sir.
Okay. How many of you have installed the data analysis tool pack in the Excel? Everybody is able to download it. We shared the Word file even for Windows users and also for the Mac users. So I think I am assuming that all of you have able to get it. Did anybody faced any problem in getting it? Okay. Okay. So I think see that many of you have able to. Yes, sir. Got it. Great. Great to see this. Great. So I'm starting it. Is my screen available to everybody?
Yes, sir.
Yeah. Okay. So in this we have 100 records. It's an hypothetical data. So it is a brief psychiatric rating scale total score for repair taken 4 times. Then we have a dummy variable, and I will explain that why I have taken dummy variable. Then we have a continuous variable as age. We have a family history. Let me have broaden my screen so that everybody can follow it. It would be bigger now, I think.
Yes, sir. It's very.
Yes, sir.
Yeah, okay. So we have a record that is always the very first thing, the very fundamental database recording is that the first column should tell you that how many individuals you have. There should be the patient ID or any specific. Basically, one should have 1, 2, 3, 4, 5, 6, something like that. It helps you in seeing that how you properly structured your data in that way. So then you have a 4 times BPRS scores. Then we have a dummy variable. So we have age variable, we have a duration of treatment, we have recovery, we have gender, and we have disease category. So of this, BPRS 1, BPRS 2, 3, 4, and age, they are the, and duration of treatment, they all are quantitative variables because they have values. And dummy variable, in fact, now family history and your gender and disease category and recovery status are the categorical variables. When I type in gender, one means male. I think I have written 1 2, so one means male and 2 means female. And disease category, you can visualize that low, moderate, or higher, something to just to demonstrate for a demonstration purpose. It is so the gender is having 2 labels only, that means 2 category 1 and 2, and disease category 1 2 and 3, that is more than 2 categories. Then so what I am trying to demonstrate that I will try to demonstrate how we can calculate descriptive statistics, and I will also try to demonstrate how we can calculate the 95% confidence interval. Then how to do a one sample t-test. Then how to do a f-test for equality of variance. Remember the assumption when I demonstrated in the class that the population variance should be is its assumption is important, and we will see. I don't think that we will take, it depends upon time, we can interpret each results or not, but we will see. Then I will try to demonstrate what is two independent sample t-test, then paired sample t-test, one way ANOVA, and then rank and percentile. So this is what I had planned. I will be explaining the purpose of dummy variable, don't worry. Is everybody able to see this data and data analysis under their tab? Whosoever would have installed, they would have got it. So once we click on data and we go to data analysis, there is a descriptive statistics. to descriptive statistics, click on descriptive statistics and click on OK. Then this says that we have to give the input range. So where this is up arrow, click on this, the input arrow, and then including the field names, click first. I have just put my cursor at the position of BPRS1, BPRS underscore I1, and then I am pressing shift button and pressing right arrow key to select for BPRS2, BPRS3 and BPRS4. So I have just selected all the field names, and then what I do, I press shift and control and down arrow key simultaneously. Then what happens, I have selected the entire data range of my data. Then you have to click on this labels in first row. You have to also click on output range. Then you have to click on again this up arrow key, and once you have clicked on this up arrow key, you have to go to summary statistics, confidence level, kth largest, kth smallest, and when everything is done, that means you have declared. So this is something like when we use SPSS, we are declaring that the variable and where to there. So SPSS directly gives the output in a separate window, but in Excel we need to specify where we need to put our output. So when you under the tab of output option, output range, click this arrow button, and after clicking that arrow, put the cursor at the descriptive statistics, and once it has done, then again click on this down arrow key of blue and click OK. You will get all the values of BPRS1 to BPRS3 and 4, everything you will get on this. So there are some messages. Let me see what is there. Sir, be slow. Please repeat slower, please. Okay. So I am trying to demonstrate it. Should I demonstrate it once more? Yes or no?
Sir, can you go for all the tests once and then you can go for...
But then somebody
Please
will be...
repeat, sir.
Okay.
That depends upon the level of cognition and the speed of other people also. That's right.
So how do we know that the analysis tool pack is installed correctly? Is it showing somewhere?
I can't help in this. What more help you use? We have given you the file, we given you the Word document, how to install.
I've installed it, must be there. ठीक है, sir.
So I am demonstrating it once again under data analysis. Click on descriptive statistics. Once you have clicked on descriptive statistics, click on OK. Once you have clicked on OK, you will see different options. Under input, you will see first input range. Then you select this black arrow key, which will be situated under right hand side of the bar. You click on this, and already I have my data selected. So once again I am selecting. So I am selecting my data on which I need to do the descriptive statistics. So I am selecting this field name. That means I am selecting the data, and I am also selecting the data and the field name. So I am selecting the entire range by pressing shift and control key once simultaneously, and then pressing the down arrow key. Now when I have done this, our data is being selected. That means the range of our data is being selected. Then we click on the output range. After clicking on the output range, you can go on clicking on summary statistics, confidence level for mean, kth largest, kth smallest. By default, the confidence level for mean is 95%. You click on this and you click OK on, and then you have to press this button under the output option, output range. Click on this, and you have to place already where I have created the template of descriptive statistics. You will found in the column M, just below the column M, after the red block. You can put your cursor there. Once this process is done, click on this blue button and then click OK, and you will get all the values of there. I think I have been somebody has some issue out of first record. You need to click last step. Please repeat. Last step is once you have clicked on the descriptive statistics, okay, then your output range pick, you have to click on output range, click at this block, uh, black arrow key, and press your cursor where I have already made the template of descriptive statistics. Is it fine now?
So first row is covered under these headings of descriptive statistics because two rows are merged here.
नहीं तो you put it at the next, जो उसके नीचे है वहां पे आप रखिए ना, cell
But
position.
will that not affect the analysis because first record will not be included in that case?
What is the question? What is the confusion?
I'm saying if we
Just go on.
okay.
अरे आप tell the question, I will resolve it. Tell me. Hello.
Yeah, I'm saying because we are putting our cursor on the third row. So will that include the record one?
Are you seeing my screen where I have put my cursor right now?
Yeah,
Where it is?
it's on the third row, M3.
M3. So it is outside my data range. I am putting the output outside the data range. So no record is going to be affected.
Okay.
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 Is it clear?
Yes.
Can I move ahead? Any question? Yes. How many of you are able to do this exercise? Please type yes, 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 yes. I want to see 150 yes. Yes. Good. Mean and other values are different. They will be different. It depends on what data is there. Might be possible that everybody has not got the same data coming. Okay. After clicking on OK, the output is not coming. Probably because you wouldn't have put the at the exact position. Okay, I am moving ahead now then. Okay. Next is one sample t-test. Now, one sample t-test in Excel, it is there is no statistical test derived in the data analysis pack which can do a one sample t-test. However, there is one function in Excel that will help us in telling and doing how we can do in one sample t-test, and that was the purpose of creating a dummy variable in our database, which you can see dummy. For the dummy variable which we calculate, which we find all the values are zero. All the values are zero. There is no other values. It is just for the purpose of declaring the input range of that variable. So if we want to do a one sample t-test, the same thing, you go to data, go to data analysis, and go to two independent sample t-test, which will be using t-test to sample assuming equal variance, because it doesn't matter, because we have two sample, we are doing one sample, but we have artificially created a dummy variable in Excel just to allow Excel to read the data in two range and complete our analysis. In that way, when you click on t-test to sample equal variance, click once, the blue will be highlighted, click on OK. Now you have to give two ranges. So first range of variable, one range, click on this right black arrow key, click on this, go on and calculate, and keeping the first B column cell, selecting the your field name, go on and select this range. So those people who would be using Windows in their as an OS in their laptop, or they will be able to do this straight away by pressing Shift Control simultaneously and then the down arrow key. So one column has been selected. Now you go to select the second variable range, which is we created artificially dummy to allow to do for a two independent sample t-test. And you do this, select this. So now your difference is there. And hypothesize main difference is that there is no difference. That means you can put the value of 0 or 40 or 30 depending upon that. So we will calculate that whether the score, so we have all the 18 item BPRS score from the range is 18 to 126. So we will assume say a median value of say 63. We put it say 63, whether on average that the value of median of this value is 63, then whether they are whether they are different from 63 or not, just for the purpose of illustration. Whether this data is following a normal distribution or not, that is not my focus of attention or demonstration right now. So we can click this, you click on label, then you click again the output range, and then you click on this left arrow button up key, and you have to put the cursor under the red block of one sample t-test at this position, which happens to be the column number Y, and so the cell position is Y3. If anybody would be using Excel quite frequently, they would be very much handy and they would be well informed. For somebody who would be new to it or totally they would be using for the first time, anywhere in Excel, if you put your cursor position, you are able to see your cell position at the extreme left hand corner. It is written Y3. So that helps you that where presently your data or you presently where your cursor or selected area is. So when you click this, you have placed this option. So as of now, you need to click on this and you completed the one sample t-test analysis in this way. So those who have typed yes, those who have typed, those who have done, you can do it. So you can see that for two sample assuming equal variance, for this it is mean is this, variance is this, variance is this, pooled variance is this, hypothesized mean difference is 63, degrees of freedom is given because 100 plus 100 is your 200, and for degrees of freedom it is n1 plus n2 minus 2, the sum of all records for the first group, sum of record for the second group, minus 2 is your degrees of freedom for two independent sample t-tests. So it becomes in this case there. So that's why the people were asking one should be little bit cautious on that what to, because Excel is fooling us, because it is giving us a degrees of freedom of 198, which is actually not 198, because it should have been actually only 98. So it is, since you see that the value of t is 2.26, which is greater than 1.96, which is the critical value that we saw below between what to z score do 95% of the values lies, it was 1.96, it value is different. So you can see that the p value is less, if p value of two tail is 0.02, therefore it is significantly different. So what does it mean? That our null hypothesis was that that this value, this sample of BPRS item, BPRS total recorded at first instance, whether these values are different from value of 63 or not, p value is significant. That means we are rejecting our null hypothesis. That means we are accepting our null hypothesis. So which means that the values of this sample mean of 100 individuals is significantly different from the value of 63. So how many of you have done it? Do you? Yes, we need to make some correction for degrees of freedom. In this case, we will have to see the t value for at 98 degrees, 99 degrees of freedom rather than 98 rather than 190, and it will remain significant even at that, because it is greater than 1.96. So I am giving 1 minute, and I am waiting that can you show the last step? Where did 63 come from? I assume, I have just hypothesized that a median value of 63, half value. That's why it hasn't come from. I'm just demonstrating it for the purpose of there. Done, but the output is different as input was different. So if you give the input as different, output will be always different. Somebody is asking, can you show the last step? Probably you people are, some of you may be a little bit not very much clear on what is the last step. The last step is where we are putting our output. Is it proper to assume mean difference from the median? You are technically correct. This is just for the purpose of illustration. We need to go uh, if I go on explaining each analysis, I don't think that I will be able to complete. Nel also, I have got a request, so I will try to demonstrate it once more. No issue. We can carry on with this session little bit late also.
So is there any way how we hypothesize this mean difference in real analysis?
In real analysis, it depends upon our review. So if you have a review of records of your hospital setting, or in where if you have, so if you want to represent our population, so that's why we need to see the review and say that if this sample mean is significantly different or same from a particular value, so that hypothesized difference is the value corresponding to which you are testing your hypothesis, that whatever sample you have got, whether that sample represents the population from which you have drawn or not. That means whether the sample of 100 individuals BPRS score can be said to have been drawn from a population where the mean score was 63 or not. That's the reason.
Okay, so,
The particular value, it's review driven.
okay, so it will come from another set of experiment.
Yes, it
So
will depend upon the review. It will just depend upon the review.
okay.
Do I need to demonstrate it once more? Yes or no?
It is clear, sir.
No, no. Okay. So I am moving ahead now. I am moving ahead to demonstrate for the F test. Now remember, when I was trying to explain that whether the sample distribution, whatever sample has been taken from a population, whether that reflects a true population or not, the assumption was that the population variance, usually when we do in SPSS, the basic thing is that the interpretation, or in fact in any software, it gives you much output, and what output to consider relevant and what output to consider a bad noise or a non-relevant, irrelevant, that needs a sound statistical perspective. That's why one should not always believe what output we get. We need to see how we have done it and what we have done is correctly or not. For example, I demonstrated in Excel, but I got the degrees of freedom of 198. It doesn't make sense to me, because I know from the theory of statistics that for a one sample t-test, for the sample mean, if you take from the population, the degrees of freedom are total number of observations minus 1. So I have to see my critical value accordingly. That's the reason. So now I'm trying to demonstrate for the F test for equality of variance. I will be little slow on this, because this is slightly, I will not say difficult, but slightly different as compared to previous two analysis. Because in F test for equality of variance, what we are trying to study now, what we are trying to make it clear, that whether the BPRS score of item 1 of a BPRS score of at first instance across the gender are similar or not. So what was happening when we did a descriptive statistics analysis and one sample t-test, what was happening, that we were able, or we were sufficiently it was feasible for us to select the entire column at one go. But now it is not possible to select the entire column in one go for F test for equality of variance, because you have a column of gender and you have a column of BPRS score, and you need to separately go for inputting the range. So that's the difference in the way we are declaring our input variable. So to do an F test for equality of variance, click on data analysis and go to F test for two sample for variance. Click on OK, and now you can see it is asking two things: variable input range 1, input variable 2. So you click on the first one, and you see, if you see the data carefully, for gender I have given a color, different color is being given. So I have to see from where I have to just in fact, first of all, I need to see where my data up to where my data is there. So my data of 1 is corresponding to row number 51, to row number 51 to row number 3 is my row number 2 to row number 51 is my first group data, and from row number 52 onwards it is my second data. So what I need to do is I need to see in that way that where my data is, so that it facilitates me in giving the selection. So what happens in this, I will go to the, once I have identified my data range, I go to this particular test again, data. I go to data analysis. I click on F test for two sample for variance. I click on OK. I click on variance input range. I click, now I have to click from the second I will select from here. I cannot select the first one, the field name, because it will be error, because the same column contains the data for male also, and the same column contains the data for the female also. Have we done the separate column for male and female, which was possible, but for the purpose of demonstration I did it once, so that you will be also be learned how to select and give the input range for Excel. So I will go on selecting. This time I will have to go a little bit slowly up to row number 50, row number 51. So that is my input range for the first gender, which is coded as 1. I go to the second second input range. I select the remaining data. Once I have selected I have defined the input range for both the variables. I will click on the output range. By default 5% is there. Click on this and click on your where I have put F test for equality of variance at cell position this, which is AC3. Once this cell positioning selection has been completed, click on this down arrow, blue key. Click on this and then click OK, and you will see that the F test for equality of variance is also being completed. So whosoever has completed it can type yes in the box. I am giving a few seconds, 30 seconds.
Sir, how is the means coming 71 in this?
Where? How
Yeah.
means? Love, it has taken the data, it has calculated.
Okay.
I have selected the area, na?
You've taken it for gender, right?
Yeah, I have taken it for gender.
Okay.
So mean and variance both.
Okay.
I am giving 1 minute more to see how many people are able to do it.
So my value for variable 2 are coming different.
It might be, sir, because it was a randomly given data.
It's not the same file.
Maybe it's not the same file. अगर सबको एक देते तो लोग नकल भी कर सकते थे ना.
Okay, okay.
Sir, you missed one observation. Maybe that's why it's coming a different average.
I have missed.
Yes,
For
sir,
the
it is
female, you
showing
have missed one
99
observation. It's only
observations.
49.
Degrees of freedom is 49 and 1 for it is 48. Yes, I have missed. Maybe I have missed
That's
one.
why there is a
You
difference.
missed the
Yeah.
52nd row, sir.
Yeah. Should we go ahead?
Yes,
Yeah.
sir.
Yes, sir. Yes, sir.
Okay. I think you people are not getting bored with this exercise.
No, sir. No.
Now, should I demonstrate two independent sample t-test because I have already demonstrated it? With the one sample which I demonstrated for F test, the same thing you need to do for two sample for gender. Should I repeat it?
Please go ahead. Yeah.
Okay.
This can be taken as exercise also.
Exercise is a separate file altogether.
Okay, sir.
Should I demonstrate it? Well, I am okay with that. Anything you say. You people say, sir,
Yes, sir.
please.
Yes, sir. Yes.
Okay, so I am demonstrating it again. So I go to data. I go to data analysis. I go to now, first of all, before I go to two independent sample t-test, I need to see what was my result in equality of variance. Now, if you see whether the result is significant or insignificant, somebody tell me.
No, sir. It's not significant.
It is not
Non-significant.
significant. It is non-significant. What does it mean?
It means that the variance is equal.
Yes, it means that the variance is equal in across gender. So in this case, when we have to do a two independent sample t-test, what type of test we will be doing? We will be doing F test. We will be doing t-test with assuming equal variances. See, two sample assuming equal variances and t-test two sample unequal variances. So click on two sample assuming equal variances, click on OK, select the data. For the same variable, this one, I think this time I have selected correctly. Yes. When one input range of data has been selected, click on the second. Click on this, then click on the output range and put your output selection point at two independent sample t-test. Once this is done, again click on this and
जो भी बना देंगे वो तो कह रही है मैं रोटी खाऊंगी नहीं रोटी
click OK. Somebody is unmuted. Please unmute yourself.
So what about the hypothesized mean difference?
Hypothesized mean difference in this case will be 0.
Okay.
Even if you don't give it, it will assume because by default it is 0.
But it was taking as 63 from the previous analysis.
Okay, so I can redo it. Thanks for getting me checked. Data analysis, two sample equal variance, hypothesized mean difference. I put it, remove it. I click on this, I click on this, I click on this, and I click on this. Now see, what is it is giving? It is giving you 92 and 95 because the first value would be 92 and 95. So you need to change this to name your correct variable like BPRS I1, for you can write it as male and you can write here as BPRS underscore I1 as female.
What is BPRS, sir?
What is BPRS? This is brief psychiatric rating scale. total score. Okay, how many of you have done it? Please type done, 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 yes sir, or whatever you feel like. Variable 2 range is the different. Variable 2 range is the same from row number 52. Should I repeat it once more? Yes or no? No. Somebody is saying no, somebody is saying yes, but majority are saying no. If there is some problem, then you can see the video file and when it will be uploaded, and it will help you in moving forward. Please repeat, sir. Okay, I am trying to repeat once more. Click on data, click on data analysis, click on t-test to sample assuming equal variance, click on OK, click on variable 1 range, up down up arrow black key, click on this. Then you need to select the data. So for selecting the data, I am putting it my cursor as cell position B2 and selecting my data in the input range first group, which is up to consisting of male up till this point. How I can get it? I have just formatted my cell position at this to find out and help me in seeing that I have to select till this point by making this entry as bold to the left hand side and filling it with a yellow color. It helps me in identifying the selection or restricting my selection to this particular area. When one input range is selected, click on this, then again click on the second input range. Then you already know that I have formatted it, so I can again click at the second point and I select the entire range. Again I click on this down blue button, I click on label. I deleted the hypothesized mean difference. That was, I click on label. Even if you can in fact untag the label because you need to edit it. Then you click on this black arrow up key. When this is done, when two independent sample t-test, you can just press your cursor here. So you see this cell position $AG$3. Whenever you put dollar, it fixes your selection area. That is so people who would be quite familiar in Excel, they would be aware of it, and some people will be interested in learning it a little bit more, I'm sure. So when you click on this, again the dialog box appear, click on the output range, it becomes this. I think this explains the thing, and whosoever has done it, somebody have already. Sir, why did we pick equal variance? We did pick equal variance because on the basis of F test result, we got the statistically insignificant result. That's why we selected the. That's why we selected the t test for equal variance. Hopefully that addresses the question. Done. Thank you. So I am moving forward to the next thing. Now, when we have done now one we have done now the paired sample. So now what I am doing, we are assuming the same thing, that BPRS1 and BPRS2, but for technically speaking, before doing the paired sample t-test, we should have also done the F test for equality of variance in the same way as we have done. So you can practice for in this way for the BPRS1 and for the BPRS2. I am not demonstrating it because it has already been done. So here I am assuming that BPRS1 and BPRS-I2 and I1, they are following the assumption of insignificant result in the F test for equality of variance, just to save time, and assuming that since BPRS was measured at one time a total score, first time, and the second time it becomes a paired data, because for all the individuals, 100 individuals, we have both the observations. For the same individuals we have two observations. So once we need to do this particular thing, what we need to do is to go on this, then go to data and data analysis, go to, you can find paired sample t-test, t-test paired for 2 sample mean, and go to OK, select the input range. So you, in this time I am selecting the entire column including the field name. It is this. Once this area has been selected, I click on this and then I select the variable to range in this way, and I took the variable to range, the BPRS I2, and select in this way. And when this is done, again I don't want to put the, in fact in this case I can put the label. I will not put anything here, hypothesize mean difference, that because it defaults it takes the value 0. I am putting output range, selecting the output range, going to this and putting my cursor position to allow me to paste my output in this file at this particular position. Click on this, and here you click on this, that becomes your, so you can see now that your mean, your variance, your observation, your paired, your degrees of freedom is 99 is fine because it is n minus 1, total individuals is this. So you can see that the two-sided p is, again, what is the result in this, significant or insignificant?
Not significant.
Not
Not
significant.
Yeah, so those who have done, they can type yes, and it will facilitate me to move forward.
Sir, can I ask you one thing?
Just
What
a
does
second, just give a second, Those who have done can type yes, 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 yes. I want to see as many yes. It will help me motivate, keep me motivated, and keep my energy up. I am somewhat draining down of my energy now, but that's fine. That was the purpose of of this workshop. That whatever learning is possible at my end, that I should try to do. Yeah, sure. Just go ahead, please. You had a one question, probably.
What does this mean? Variance and critical, T critical, P critical, sir?
I think I explained all this thing in my lecture. The critical region and t-test statistic, below what Z scores you 5% of values lies, below what Z scores does 95% of the values lie, 2.58, 1.645, 1.96. You would have been in my lecture in that time, na?
Yeah.
So these are the critical values. That means t-test one critical. That means if you are assuming you are making an alternative hypothesis, then you have to see that whether your calculated value is significantly different from 1.66 or not. Now what you is low or below or above this. Now what is our value? Our value is 0.59, which is less. So it is falling in the acceptance region. So we are accepting our null hypothesis.
Okay, so these will remain same actually every time.
Yeah.
Okay. And then this variance, sir, where it is coming 1,000, 6,000.
It is on the basis of the data that we gave, na? Well, we have selected the data. So on the basis of that data is estimated the variance.
Okay.
So if you want to find out whether this value is true or not, there is a function to tell. Let me demonstrate. There is a function called, in fact, this is called as variance. I like is equal to VAR. And I select this entire column and I enter this. See what is the value? 1000.1 if I have calculated it, and if I have done this F test, what is the value I am getting? It is giving me, what is the variance? It is 1000.12, same. So you can calculate also, you can recheck also. So it depends upon the familiarity with the Excel. It is possible to recheck many things.
Thank you, sir.
Thank you. Can I move forward? So whosoever has done, again, they can click, they can type yes, 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 so that it facilitates me in keeping a track that you people are following, and it is nice to see. Good. Okay, so can I move ahead now? Now I want to do a one-way analysis of variance even in Excel. It is possible, but a slight different. I need to do something in this. Now, can you anybody tell me where I can how I can demonstrate the one-way ANOVA in Excel? Which variable should I take? Will I take gender or recovery or family history or disease category?
Disease category, sir.
Why?
Sir, it
Anything
is
that
having
has
three
more than two
categories.
Yes, very
More
good.
than two
More
categories.
than
Yes,
two variables.
it has more than two variables. So
Continuous.
what will happen? What I will do? I will try to first. There are you need to slightly work with the data to work for ANOVA in this case. Now what I will do, first of all, I will see that where are my variables of gender of disease category in three categories, what is their range. So this is the first range. So I will first of all copy this entire range. Okay, this entire range I will just copy without the field name, only for the first group, for the first category, and I will paste it in at this cell position, and I will just control C and control V. I have done this. Okay, now again, for one group I have done, I have to need to go for the other group also. So I should remember that my row it is at this position, row number 28 for the second group. So up to 28 is the second. So I will go on and said where this two is finishing, so that it helps me in keeping a track of where my data is in the second group, what is the range of my data in second group. So when I go down, I see that two stops at something at this point. So I will select this. What was the row number? 20? 20?
8, sir.
Yes,
28.
28. So once I have done this,
28, sir.
it is 28. So I have done this. So I have selected the second this position, and I will click on the second adjacent where I put. So this is my second. So what will happen? You can, to facilitate, you can also do one thing. You can put it little down, and you can write here D1, D2, and D3 as your to identify you that it is belonging to the disease category 1, disease category 2, and disease category 3. So now you want to select for third variable for the third disease category, for the last one for it is. So where it is, I will need to see that where 2 has stopped and where 3 is starting. So 3 is starting from here. So I go to this position and I select this entire data. I control C it and I will paste it in the next column. Now why I am doing this, it will be clear in this, because to do ANOVA, it will be clear when I demonstrate. So whosoever has done this till this point, please they can type yes, 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 so that it helps me in keeping track of that data collection procedure is being I am giving 1 minute. Somebody wants to ask something? Okay, so I can see that many of people are following. Good. I think you missed one value in D2. Maybe
Yes,
in
sir. It starts from 34 and you have
okay.
started from 23. If you can check it again.
It starts from 63, third group. It is fine. It is this third group, 63.
No, sir. So check second D2. So check
Yes, sir, no.
D2.
So second group starts from 34.
Yes, just check D2.
So you missed the 28th number value.
Why? And
Yes.
यहाँ से लेना है मतलब 111 से लेना है.
नहीं sir, 28 serial number से देखिए एक बार.
28th serial number, yes, sir. That in the
हाँ,
value stuff.
yeah, 34, yes. Sir, 34 sir.
This one?
Yes.
Good. Thank you. So copy and fine now.
Yes, sir.
Okay. So when we need to, if you need to do ANOVA, what we need to do is we have to again go to data analysis. From data, go to data analysis, and I think one way ANOVA is somewhere ANOVA single factor. ANOVA single factor. So you can see ANOVA single factor, ANOVA two factor with replication, ANOVA two factor without replication. So it is this. You click on OK, but extension of this is more tricky than this because you need to know how to work in Excel in terms of data. So that is now it happens what you need to select the entire range D1, D2, D3 to data, and you can see that the complete data you have given. So it automatically counts you in this way. So Excel is not allowing me to select likewise for F test for equal variance and two independent sample t test or paired sample t test, everything, but it is giving me only one option to complete the entire range. So once this has been done, you click on this. You can click on label, you can click on the output range, click on this arrow key, and you can paste it here. And once that is done, click on this and you click OK and you get the ANOVA result. So you get D1, D2, D3. What is means? This is category 1 count. So you can see that total count is 26, 38, 36. It didn't dependent. It was not dependent upon whether some values are in the other column or not, or some are missing here. It doesn't depend because it takes the actual data into count. And it based upon this, it calculates the values of variance and the other factor. And you can see it is giving you also the analysis of variance table. Now can anybody interpret whether what is the result of ANOVA in this case?
Non-significant.
It is non-significant because p value is this. You can also check this by that F critical is given as 3.01, 3.09, and your calculated value is 0.157, which is less than this. So your test statistic value is lying in the acceptance regions. That's why we will be accepting the null hypothesis, and we will be reporting that the result is statistically insignificant. So that's the basic purpose to start in Excel. It is possible to do Excel many things, but it is not possible to do many things in Excel. But if you are a programmer and you know the programming, it is possible to do even factor analysis in Excel. That is there, but we need to have some programming skills and other things. That's why I planned also R, but R doesn't I don't have time to switch to R and demonstrate. We will see. So this is there. And now one last thing is rank and percentile. It is also very simple. Rank and percentile helps us in giving us is it fine? Can I move forward?
Yes, sir.
Okay, so click on data analysis and go to rank and percentile. click on OK, and here I am just for the purpose of demonstration. Again, I am taking the BPRS score of the item 1, and then you click on this, and you can put the label in first row. You click the output range. You can click this, and then you click on the output range of where I have put in rank percentile. So if you click on this, it will give you the complete positioning of each data point in your, please write, it is this. So what it is, let us see what it is giving. It is giving us that point, that is your data point, that is your fourth point, 34th, 47. It has ranked, so it has sorted your data in the descending order. So the value which was highest and the value which was lowest, it is being sorted, it has been sorted in this way. And you can say that it is the rank. So you can see that what is the respective rank, that means how many. So it means that if I am taking here 95, that means 95 percentile means there are about only 1, 2, 3, 4, 5 individuals which are above this percentile score, and their rank is, and then there is rank. So it is what it is having. It is first of all giving, it is giving you 4 column. First of all, it is giving you the data point location. It is giving you the value of your inputted data. Then it is giving you the rank. That means if I short it, the entire data where it will go. And when then it is giving me the percentile rank, that percentile position. That means this specific individual is falling in which percentile range. So it is, you can see if the ranks are repeated, you are getting the same percentile rank, 96.9, 96.9, 96.9, 96.9. So this helps you in giving the, sometimes it was the question which was being asked by one participant, that why median is not used or it is a skewed data. So in this case, we always, when you have a sufficient sample size, we should go for some statistical cutoff. Like the one statistical cutoff is a median, but median only tells you to bifurcate your data if you want to do some categorical analysis, which is not advisable as per the statistical theory, because when you have a raw data, category of a creating a categorical data from a continuous data should be the last resort. So this is what that completes our day, what I had planned. Anybody have to ask anything? Those who have done this exercise can type in yes, yes, yes. I am giving 1 minute and then I will take questions. Please repeat ANOVA. Okay. Should I repeat once more? Okay. I am repeating ANOVA. First of all, I will select for the first disease category the data. The first disease category data is in this range. Okay. I copy it and I pasted it under the section where I have put it here at this position. Now I go to the second position for the second group. Second group starts from this position. That's why it was purposely given yellow, pink, and other color to facilitate, because if I would have made my window so small, so it would have been difficult to explain. That's why I made it large for the purpose of demonstration. But now I am made it small just to save time. So this has been the second data input range has been selected, and I put it in the I put it in this column. When the second group data has been copied and pasted, I go to the third group, which starts at this point, and I select this, and I put it on this particular position like this. So once my complete data has been is copied and being pasted in the required area, because Excel allows me to Excel allows me only to give the data selection input range criteria, selecting that input range only once. So when I click on data and I go to data analysis, I have to click on one way ANOVA single factor. I click OK. I have to select my entire range of data which I have copied and pasted from the actual data. So it is this. I select the entire range, including even the missing cell positions for some group. And when this is done, I click on this position and I click on output range and I put my cell position here to see the output, and I click on OK. I get the result. This is ANOVA. Hopefully this facilitates the repetition and it would be fine. So you can see that some data are being missed because of my copy paste. I think it is fine. One has to be little bit, give the area a little bit more, so it helps me in there. It's fine. So that's completes our complete. So in fact, I was able to what I planned for the day, and I was able to translate that. And hopefully, this would have been useful exercise, because maybe for many of you, it would be new. Somebody has requested to repeat the percentile position also once more. So I am trying to demonstrate it once more. So when you have to go for this, you again click on data, you click on data analysis, you click on percentile and rank and percentile. Once you have selected this, click on OK. Click on specify the input range of data. Once that is done, click on this, then click on output range and click on to where you want to paste your output. I am pasting it here only, and then I am sending is OK, and that is done. So you see, those of you, many of you would be using SPSS also, and the basic difference in SPSS and Excel is that it is, please mute yourself. It is possible to in SPSS, when you do the analysis, a separate window for output is given, but in Excel, please mute yourself, and when you use the Excel, you have to specify the data range also and the output range also to facilitate the analysis. So many things it is clear. I think the basic purpose of today's exercise was a practical demonstration, as well as the hardcore uh, concept of hypothesis and research process, p-value, power, all would be there. So if still anybody wants to ask something regarding this exercise, I've already made it clear, but for the sake of completeness, I am demonstrating it, saying once more that this exercise was being planned for a practice exercise, and you have one exercise also by the name QDA and dot underscore exercise. You do that and put it on the browser page, and I was happy to see that all the organizing team was very much pleased to see that many of you have able to followed all our instruction and have completed the worksheets and have completed. Many of you, it is not possible to do it in R. I am not, but the exercise is in R. You don't, you just remove that part. You don't do for R, you do for Excel. Anybody has any question? They
So
can.
if tomorrow or maybe in subsequent days, if the time allows, please give a glimpse of the R, and in that you can just go in one flow, and we can later watch it on YouTube, so that we can have at least an understanding of how it
Yes,
goes.
I can. I will demonstrate R tomorrow.
We will not go ask so many
in
questions, so
fact,
that it
I
saves.
can. I can just demonstrate in a 1 minute, because command is there. I can run it completely, finish it, but I will not be able to explain. So that doesn't make sense. But tomorrow we will be starting with R. I will demonstrate R, and then Dr. Vivek will take on for the correlation and regression.
Thank you, sir.
Thank you.
Sir, is there any way if we want to change range or mean for given analysis without overwriting.
I didn't get the question.
If we have, for example, we have calculated ANOVA.
Yes.
Okay, and after doing the test, test sample t test. Okay, so if we have calculated once, do I change range or mean? If I want to change mean or range and see a different result, can we do it without overwriting or doing again? Instead of doing again, we can do it.
I'm not clear. What is the question?
सर एक्चुअली हाँ सर क्वेश्चन ये है कि अगर हमने सैम्पल टी टेस्ट किया है या पेड सैम्पल टी टेस्ट किया है और अगर हम रेंज को सिलेक्ट कर रहे हैं और आउटपुट मेरे को मिल गया एक पर्टिकुलर रेंज के लिए हमें आउटपुट मिल गया है, लेकिन अगर हम चाहें तो जैसे हम लोग पाइवेट में करते हैं, कुछ चेंज करते हैं, रिफ्रेश करते हैं तो डेटा अपलोड हो जाता है, वो करके ये
नहीं, इसमें नहीं होगा, इसमें नहीं होगा, नहीं, because in this what happens, it is like suppose you do an SPSS and you have entered one data and you have made a syntax, you have to run that syntax for that variable, then only it will rerun. It will not automatically rerun because the data selection is changed. If any data is changed, because in Excel when you are doing some, you have two columns and you have created some function, that what we were trying to demonstrate yesterday, it was fine, but once you have changed the cell position or changed the data, that function will change but the analysis will not change. You have to redo the analysis.
Okay sir, thank you.
There was some question. Thank you for compliments and we appreciate that there.
Really very much thank you sir, really nice. Hello, I would like very much thank you sir.
Thank you.
Really very business nice sir.
There is a question from somebody regarding degrees of freedom. Yes, it is there. For paired it has to be n-1, so you need to check the before reporting. It is if it is it has to be n-1, the total degrees of observations -1. It can't be 48. That is correct, but since because of purpose of demonstration only I am giving, that's why it is different.
Sir, this thing I tested in both SPSS and Jamovi also. For same data sets, say for example 25 values, if we are applying the paired test, it's counting it as 25 minus 1, 24 as degrees of freedom.
Yes.
But if we go for the unpaired, then it counts it as 48, and the t values and t statistics
will change, because for a paired data, if you have 25 observations, for 25 observations you took the observation first and then you measured them again, so they are not independent but they are paired data. So it for a paired data, the degrees of freedom are total number of observations -1, and when you have unpaired data or a two independent sample t test, it is n1 plus n2 minus 2, which means sum of all the observations in both the groups -2. That is 48. So once you are treating that as unpaired, it is 50 plus it is 25 plus 25, that becomes 50 minus 2 is 48. And it will have its implication on the t-test and others. That's why only the blind use of software is not advisable. We need to know what exactly is the statistical principle behind that.
Yes, sir. This part I am getting a little confused. For paired data, shouldn't this our ability to detect the difference increase and the p-value should decrease rather than the opposite that is happening?
Sir, this is the fictitious data. This is the demonstration purpose, random data. So just only for the purpose of illustration, this was demonstrated. That's why.
Okay, sir. Okay.
So you can use this as an exercise. For LDA and CDR, have patience. We have longitudinal data analysis and CR, which is your correlation analysis for tomorrow and day after tomorrow. There we will be there the same. Now the same file you will be using, this practice file for longitudinal data analysis as well as your CR data for the correlation and regression, because the data is the same. That was the purpose of illustrating everything in the one sample, two sample, one way ANOVA with the same two-way repeated ANOVA, disease category, duration of treatment, it all will be linked. But that will become more clear as we move from for the coming 2 days. So that is from my side, and I hope you all would have. Is there any? Please clarify the home assignment once again. What clarification is required? Yes, practice and exercise data are separate. You have to upload only the exercise data set, but don't load it now. Once you complete all the exercise of this data, including today's, the quantitative data analysis, if there is please facilitate the recording of yesterday session. It gives, please allow us some time. We need to process the videos. It takes time and it will be uploaded. It will be there. Everything you will be getting. I promise on the first day, you will be getting more than that. Exercise data is the one under day 5 exercise. See, it might be, what is the question? What is the confusion? Any confusion is there? Please ask. Is there any confusion with the exercise? Please unmute yourself and ask.
Sir,
Yes.
sir, are we supposed to do the QDA exercise for
Yeah,
the
I couldn't
home?
get you.
Sir, are we supposed to do the QDA exercise Excel sheet for the home assignment?
QDA is quantitative data analysis. What I have demonstrated it today. Exercise you have to do. I
Okay, sir.
created two files, practice and exercise. Practice was for the purpose of illustration, and exercise is so that you can do it. So it will be a double practice for you also. You will be able to be more informed about how the process goes. That's what the purpose. Now the same exercise will be used for the coming 2 days. The same data set. We are not going to post any separate data set for longitudinal data analysis or for your correlation and regression. And many of you have already filled in, submitted the session of the exercise, but don't submit it now. This needs not to be submitted right now, because you will submit it only when all the today's exercise, day after tomorrow, tomorrow and day after tomorrow, because same data set is being used. So somebody when asked what to do in CR and LDR, that is the longitudinal data analysis and correlation regression analysis, it will be there. So once you will, only one sheet now will be loaded, it will be fine.
Sir, a syntax file is available for what we did
What
in
syntax
Excel?
file?
Sir, whatever analysis we do in Excel, like descriptive we calculated, is there?
It doesn't have a syntax file.
Okay, sir.
When you know the programming in VBA, that is possible to create the syntax like we do in SPS.
Okay,
But
sir.
for that, we need the VBA programming skills. Okay, so thank you for the compliments. And as the day progresses, more and more little bit, we will go on a more serious side, more sophisticated side, because tomorrow session is important. It will be good that as maximum as people you can join. That will be of great help to all of you. When the videos are uploaded, it is up to you you can practice any day. Video can't be uploaded for the coming days before, it has to be after that day.
Sir, am I audible?
It takes some time to process a 1.5 GB file. That's why it takes some time to upload the videos.
Hello.
Yes, somebody's want to say something.
Hello?
I can't hear.
Am I audible, sir?
No, very slow.
Okay, sir. So I'm typing in the chat box.
आप थोड़ा तेज बोल सकते हैं.
Sir, I'll have to travel tomorrow. So.
आपकी आवाज नहीं आ रही. I can't get you. मेरे को कुछ. Thank you. Good night. So with this, we end the day, and it was nice to keep you all. I think have a great day. Good night. Thank you. Thank you.
Thank you, sir.
Thank you.